Welcome to the 17th SRB session. I think Dave is going to join us later, so he normally does the opening and reviews the agenda, but I'll do that to get started. So just a reminder that this particular meeting within the SRB workflow is mainly focused on the upcoming assessment for the year and things that we may have asked for back at the research meeting in June. That meeting is now documented in the SRB017 document, and we'll be going over some of the requests and things that we had made in there in this session. Do we have any observer updates? Maybe we can start with Carrie and
Sure. Can you hear me?
yes.
Did you want me to go right now, or were you gonna sort of go through more agenda, or?
Unfortunately, I can't scroll through this agenda myself.
Sure.
I don't know who has control of it, but.
Yeah, Sean, we have control over the agenda.
Okay. Can you make it bigger? I mean, it's the usual. I mean, everything is starting to look. I mean, for me, after all this time, of course, but you know, things should be starting to look familiar with the order of operations here and things we go through. I meant actually make it smaller so we can see the whole agenda rather than just a little section of it. Sorry.
Okay.
So we get kind of the 10,000 foot view here of what we're going to be doing.
Okay.
Okay, that's good for now. So for today, so normally we start out with the observer updates, and so we'll do that in a minute. Thanks, Carrie, for suggesting we go over the agenda. So we usually go over the Fishery Independent Survey, which and then into the stock assessment. Then normally we go through the MSE and then the biological research program, but it looks like we'll do more on the biological research program before the MSE. I don't see it. I don't see it here. Can you flip down? Yeah. Yeah. So I think tomorrow, is it at 10:30? We have Trevor Branch coming to provide his draft report on his MSE review. So I think we're going to slot that in tomorrow morning.
Sean, just very briefly on that agenda, I think there's a numbering issue, nothing major, but the MSE is also 6 as the biological ecosystem science program, so that needs updating.
Does somebody have, maybe somebody can take control of that and make that update and also insert Trevor's presentation for tomorrow. I believe it was scheduled for 10:30.
I think you're right.
10 a.m. 10 a.m. Okay, is there somebody that can do that? Josep, are you in control of this?
Yeah,
Okay.
no, we have the PDF on screen, but we take a note of that and we'll revise the agenda with those specifications. 10 a.m. for the review, followed up by agenda item 6, which will be the biological research update, and then followed up by 7, which is the MSE update.
Thank
Yeah,
you.
and you'll have to change the review of the draft to 8, just so they match up with the agenda items at the top.
Yeah, everything, yeah, all the numbers will be changed there, yeah. We'll revise this and we'll provide that probably right after this meeting.
Thank you. And so it looks like Thursday will be dedicated to drafting the report, as will Wednesday afternoon, depending on timing. Sven, where are you now?
Oh, I've moved an hour west. I'm in the UK now.
Okay. So you're 9 hours from us, I believe?
No, 8. It's quarter to 9 now.
Okay. So I think what we did in June was, it's getting late for you. So by the time this meeting's over, we don't expect much from you, but if we do some drafting in the afternoon, then we'll send it off to you and you can.
I can do it during the day, exactly.
Yeah. Okay. Any other additions to the agenda before that gets updated? Okay. All right, now we can get into the observer updates. Take it away, Carrie.
Okay. Well, I think mine is going to be pretty short today. I think the main thing that is coming up for this round of interim and annual meetings is taking a look at spatial MSE results. MSE results are allocating catching across the regulatory areas, and so I think Alan has an MSE Explorer tool that I imagine we'll be looking at, which is really great and has been really great for the MSAB members to play with in order to get a handle on what management procedures they like and things like that, and what they feel like is performing well according to the performance metrics. And I think one of the challenges moving forward between now and the annual meeting is kind of making sure and bringing all the commissioners, finding ways to communicate all of this information to commissioners, some of whom have pretty limited schedules. And in terms of just in terms of, you know, the MSAB meetings are like a week long each, and so they don't all have time to attend. So I think my one comment is, as we go through, maybe we can all think about like what are efficient ways to communicate this type of information to people in those roles. And I think I'm gonna leave it at that.
Thank you. Yeah, that's a good suggestion for us. Some stuff for us to think about as we move through particularly the MSE section. Anne Marie, are you here? I think so.
Yes. Can you hear me?
Yep.
Okay. Yeah, also pretty short this time. I think the only actual meeting that we've had since the last time we met the SRB was the work meeting, which was last week. So I think the only real update based out of that is that I think the commissioners were pretty happy to see a lot of the items that they raised in June, or that I brought to your attention in June, but they had been thinking about earlier, was brought up at the work meeting. And just in terms of what those were, because that was a few months ago for everyone here, just the questions around the FIS redesign, both in terms of process, but also in terms of what it means for the longer term. And then the stock assessment, new information around commercial sex ratio, length-weight relationship, the MSE around tight timelines and new models, kind of, I think, seeing that you guys have it on the agenda to review, they were happy to see that. And then also, as Carrie mentioned, kind of the interpretation of model results being a learning process is still in there. I think something that did come up knew from the work meeting, there was a lot of interest from the commissioners around the migration assumptions that went into the MSE model. And I think they're just trying to figure out, like there's a difference between the observed migration data and then the modeled migration between some of the regions. And they're just trying to figure out what does that mean and what happens if the operating model has incorrect data. And then I think probably an extension off of that is that there's a lot of different levers in the MSE model that can be changed. And so is there something else that could be causing migration? Is there another lever that could be changed to get us to the abundance data that we see, but isn't migration? I guess is probably a not yet clarified question. And that's about it.
Thank you. Any questions or comments around the observer reports? Updates? Okay, hearing none. We are blazing along then. I think we were just going to note those other issues within agenda item 3, that they are in those reports if people need to see them. So I think we can jump into agenda item 4.
Sorry,
Hello?
Sean.
Yep.
It's Sven. Did you attend the meeting, or did you just give a presentation or a report to them?
The work session?
Yeah.
Yeah, the work session last week, I just reviewed some of the key recommendations, particularly requests that we made from our June meeting.
Okay.
And then picked a few areas that you guys had highlighted in the comments, the kind of pre-meeting comments you had sent to me. And I went over some of those.
Okay.
Which there weren't too many comments on, but they had a couple of other clarifying kinds of questions.
Okay. I was just wondering, because we didn't have that last time, did we?
No, that was the first time I'd done one of those work sessions.
Yeah.
So it was
All
new,
right.
new to
No worries.
me. And
yeah, Sean, I thought that was really helpful to have that little bit of discussion amongst the SRB there before the meeting here.
yeah, I found it useful too, to kind of dig into the documents a little bit earlier, even if briefly, and then get kind of a gauge for where people are at as far as what they thought. So
yeah, I guess I would, given the fact that I was on vacation and scrambling to get on vacation, it would be nice to have a little bit more notice next time, if this is going to be a recurring theme.
Yeah, that's true. It's something that, I mean, I think I contacted you guys the day I was asked to do it. So, but yeah, in June, I think we can, if we're expected to provide that presentation, then yeah, maybe we can have a little bit, a small amount of time in our June meeting, at the end, just to scope out maybe a brief presentation for the work session, if that's going to happen there.
Well, though I was under the impression that the questions you asked were in relation to the documentation for this meeting as opposed to the last meeting, so we couldn't have done it then. But
well, there,
maybe
for the review, the bullet points, like I think we had 19 requests from the June meeting.
Okay.
And of course, I didn't go over all 19. So,
no.
What we could do in June is decide which we want to focus on.
Yeah.
That way. Anyway, something to keep talking about as we go along. Okay. Shall we move to agenda item 4? Dr. Webster?
Hi.
Hi.
Give me a second.
Okay.
Please. Okay, can people see my presentation?
Yes.
Thank you. Okay, good afternoon, board members and everybody else. Happy equinox. This is a short presentation of preliminary results of the 2020 FIS. There are not a lot of results so far of the 2020 FIS. Data are still being checked for quality. Errors are being fixed. And so in general, by this meeting, I won't have a lot of actual model results to show you. I was hoping I would have more this time around, but that was a little unrealistic. But this will give a review of what might have changed in terms of our data and what we have to date. So I'm just going to make that. There we go.
Ray,
Okay.
sorry to interrupt you. This is Ian. I just wanted to alert the SRB and everybody else that we had some publishing. We had a breakdown in communication on publishing. And so if you had been looking for these presentations prior to the meeting, you may not have seen them on the website. They didn't actually get posted out, I don't think, for public use, but they are all there now. So if you want to go to the website and download a PDF of each of these presentations, you'll have that to follow along as we go. Sorry to interrupt you, Ray.
No, thank you, Ian. That was worth pointing out, and I apologize that got to you so late in the piece. We hope that you'd have a chance to review this before today. Okay, the 2020 FIS. So this was the first year, as I'm sure you're aware, in which the FIS design was based on the full grid of 1890 stations that was the result of our 6-year expansion program completed in 2019. So prior to that, we've had regulatory areas that have been fished based on a design that essentially was developed in 1998. But we've augmented that design substantially, increased the number of stations by at least a third through our expansion program. And this design was based on that expanded grid. So we're not treating the expansion stations from that program as expansion stations anymore. They're now part of the full grid, and a station is a station, whatever depth it's in and whatever its previous history was. But due to budgetary constraints and the impact of COVID-19, the implemented design was reduced in spatial extent from designs proposed by staff or approved by commissioners at AM 96. And we reviewed that in more detail at the previous SRB meeting. But this is a map showing the implemented design in 2020, which was successfully implemented. And so we have 100% coverage in regulatory areas 2C and 3A. We fished, so the orange stations are sampled stations. The purple are the unsampled from our 1890 station grid. So we had 100% coverage in 2C and 3A, and in most of 2B, except for the least productive parts of 2B, the inside waters of Vancouver Island, where catch rates, when we last fished them, were close to 0, and the waters on the west coast of Vancouver Island. 3B, economics dictated that we only fish the eastern portion of 3B. And in that portion of 3B, we fished at a rate of 60%. So for an overall sampling fraction for 3B of 35%. In 2A, 4A, 4B, and 4CDE, there was no IPHC FIS sampling in 2020. In addition to our standard survey protocols and purpose, we also did a second gear comparison, comparing snap gear and fixed hook gear. Fixed hook gear is the current gear that we've been using on our set line survey, the standard gear that we've been using for the surveys at least since 1993. which is the length of the data series that we include in the space-time modeling. But a lot of vessels are fishing snap gear now, and so we're exploring whether we can integrate that, make use of charter vessels that are fishing snap gear in our survey. But before we leap ahead and do that, we want an understanding of the differences between how these gears are operating and their catch rates in particular. So in 2019, we did a comparison in all of regulatory area 2C. And in 2020, we did a more limited comparison in the St. James Charter region of regulatory area 2B. And to give you your bearings, I believe this is the southern point of Haida Gwaii. If you can see my mouse down here at bottom left. So a smaller footprint for the comparison this year, but it should give us some more information to determine whether the calibration, the differences between the two gears that we saw in 2019 are consistent among in different geographical regions. And we're proposing to do a similar comparison in 2021 as well. So all stations are fished twice with a random selection of gear order. And you can see the fixed hooks were fished early on the left panel, and then they were the second gear to be fished in the stations on the right panel. And I've looked at the data preliminarily, and so far, without having undertaken the modeling, it does look like the results are quite consistent in terms of the differences between snap and fixed gear and the catch rates of halibut between the two comparisons, 2019 and 2C and 2020 and 2B. We'll see more of that more about that in the interim meeting. So some updates on data inputs. As usual, we update a timing adjustment, which reflects the fact that the survey is undertaken at a different time each year in relation to the how much of the fishery has already been prosecuted. And this adjustment particularly affects regulatory area 2A, where up to 80 or more % of the removals occur prior to the midpoint of our set line survey. So this is an adjustment for that. And we, following your advice a few years ago, we are doing this on a one-year lag basis. So we're updating with the 2019 data, and we just use the adjustments from 2019 for 2020 as well. The NIMS Bering Sea Troll Survey was not undertaken in 2020, and it's an important data source for regulatory area 4CDE. However, the Alaska Department of Fish and Game Troll Survey for Norton Sound was successfully completed. And so in 2020, even though this is a relatively small survey in the far northeast of the Bering Sea, it provides our only direct source of data in the Bering Sea in 2020. As in 2019, and to give you another sense of how limited that data is, I believe they caught 13 fish, Pacific halibut, and that was an increase from last year. As in 2019, direct measurements of weights will be used in computing weight per unit effort indices for the space-time modeling. That was something new in 2019 where we introduced provided scales to the charter vessels, and fish were directly weighed for the first time on a large scale throughout our survey in 2019 and again in 2020. Okay, results of the 2020 FIS modeling. This is very short. The data are still in preparation, particularly the weight data are being vetted at the moment. And so no modeling results of the data are available for areas sampled already in 2020. The raw data indicate that catch rates were generally stable in the regulatory areas that we did fish, particularly in 2B, 2C, and 3B, and up somewhat in regulatory area 3A. And this is the timing and the hook competition adjustments were not reflected in those in that summary. And we note that sometimes those adjustments, particularly the hook competition adjustment, can have a noticeable effect on the magnitude of the changes and the direction of the changes from one year to the next, depending on the amount of competition with other species that occurred on our survey. But we did have 3 areas with no data in 2019 and 2020, and so I haven't done some preliminary modeling of 032 weight per unit effort in regulatory areas 2A, 4A and 4B. And so in the absence of data, these estimates depend on past observations via temporal correlation and on covariate relationships estimated from the historical data time series within the space-time models, as I'm sure you're now well aware. So it's entirely dependent on what we observed in the past. So what you would expect, and what we did find, is that the estimates are going to be very similar to what we got in 2019, but with greater uncertainty. So this is the preliminary estimate for time series for regulatory area 2A. And so the purple points and line and shaded regions represent the 2020 output of the models, and the reddish colors, pinkish colors represent what we presented last year in 2019 and updated last year. And so the difference between those is really just the addition of a terminal year. We've now modeled 2020. We could have done it last year too, because there's no new inputs, but at the time, of course, we didn't know that. So we can see that the means are, to all intents and purposes, the same. They're well within the uncertainty, just a little bit of drift upwards in the terminal year. But the uncertainty is much greater than that change. And as you would expect, the uncertainty is much larger in the terminal year as well. In the absence of data, the coefficients of variation more or less, well, they can be up to twice as large as they are if we observe data. But it's not, the uncertainty hasn't blown up. We still have a reasonable handle on what's going on in 2A, noting that large changes typically don't occur over a one-year period. You see a few of them in there, but for the most part, the changes that we see in that historical time series are well within the uncertainty between 2 years. So I think we can still be confident that the true value for, while there's a chance of some bias without data, we can be reasonably confident based on what we've seen in the past. The true value is still somewhere within this interval that we're estimating around the point estimate. Likewise, in regulatory area 4A, we have a mean that's essentially the same and greater uncertainty, and 4B as well. I think the means are practically the same there, and the uncertainty is increased. And I'll talk a little bit more about quantifying that uncertainty in the second presentation coming up shortly. So that's it for what I have so far. The bulk of the work is going to be done in the coming weeks in preparation for getting things together to provide Ian with some time series to put into the stock assessment. And so the next time the public will see, the results will be, formally will be at the interim meeting. So our recommendation is simply that you note this paper, which provides an update as best we could on the space-time modeling inputs for 2020 and some preliminary results. I'm happy to take any questions on this.
And Sean, how do you want to do it? Should we jump in, or you want to moderate?
Yeah, I don't think this particular software has a hand raising. Does it have a hand raising thing? Let me see it.
Yeah.
No, it doesn't really have a hand raising. Anyway,
I don't think there is.
I'll just go around. So Olaf, if you have a question, you go ahead.
Great. Thanks, Ray, for the presentation. Exciting to see that your Canadian Journal paper came out as well. And I already passed that on to a few other people because I think this is just such a cool survey and so well done in general. I just had a quick question about the hook competition adjustment. Can you talk a little bit more about that? I don't remember reading about that.
Thank you, Olaf. And probably something for a future meeting would be to have a session where we just review all the inputs to the space-time model and the number crunching that's involved before we even put the data in. But the hook competition adjustment is something we've been doing for over a decade now. following concern from stakeholders that there were factors affecting the survey, affecting the catchability of the survey gear that might in particular vary geographically. And so this was something that we did have information for that we could do something about. A lot of other factors that we can't regarding catchability. So the idea here is that there's more competition. Okay, there's more competition. Other species or just a large number of halibut competing with each other, then the baits are going to go more quickly, and you'll end up with fewer baits returned on the gear. So you're going to get more. So the key data quantity for this adjustment is the number of baits or the proportion of hooks with baits returned. So the baits could be stolen by fish, or they could be have another species on the bait, or halibut on the bait. It doesn't really matter. We care about the baits that are coming back as a measure of competition. So when you have a lot of baits back, there is the assumption is that there's relatively little competition for these baits, and so the halibut that were there had plenty of access to those baits. And so the adjustment assumes a exponential form for the rate of removal of baits with time, and that leads to adjustments that are a positive adjustment relative to the average for stations with more competition, and a negative adjustment for scaling down of the weight per unit effort or numbers per unit effort for stations with less competition. So we're trying to adjust upwards or downwards to account for the fact that in some cases halibut were more or less able than others to access the baits. And so we have, I can provide, weird clicking somewhere. I can provide links to our past documents explaining the methods underlying this. It was originally developed by Bill Clark, former assessment scientist, and we've developed a little bit further since then, but I can provide links to the documents explaining the mathematical and statistical ideas behind this. So,
thanks, Ray. That was very helpful, and I'd love to see those documents. Just to quickly follow up, is this a big effect? Does it alter things qualitatively, or is it just trimming around the edges? And does that depend on the area?
It's not a marginal effect. It can be a big effect. So, okay. For example, and it can change from one year to the next. And when you look at it, you can almost always explain these things looking at the actual species that have been caught, and often it relates quite well with what people are saying on the ground. We say, well, it's a lot of dogfish in Tubi this year. What are you doing about that? And we can say, well, yes, we found that too. And so we're adjusting things upwards based on our competition adjustments. So I looked at the average adjustments this year, for example. That's what is closest to my head at the moment. And it can vary from, say, an average adjustment of plus, talk about it in terms of an adjustment factor. So you might have a mean adjustment factor of 1.4 or 1.5 in 1 year. So that means on average, the station is getting a bump of 40 or 50% on its observed raw weight per unit effort. And it might go to the next year to an adjustment of mean adjustment of 1.1 or 1.2. So that you will see as a change from the raw data, which people often see first, and to the final model data. And so people have in the past wondered, well, is that the space-time modeling that's doing that? And no, it's most of the changes from the raw data to what they see as the output from the space-time modeling is coming from the addition of the competition adjustment. So it's not a small thing. But in most instances, what I've what it seems to have done is, well, maybe saying most instances is a little bit much, but what it often seems to do is smooth the series out. So it takes away some of the variation that would otherwise have been due to the changes in competition with other species and among themselves from one year to the next. So it's doing exactly what you'd like it to do, but it's not a trivial adjustment. What is a trivial adjustment is that timing adjustment I mentioned earlier. Except for regulatory area 2A, it has really no meaningful effect on the results for other regulatory areas where close to half the catches removals occurs prior to the survey, and the harvest rates are low enough that it doesn't matter. Realized harvest rates are low enough that it doesn't matter anyway.
Mm.
Did that help?
That helped a ton, and I think I'd at some point, not now, but I'd love to hear more about catchability in general and what other factors might be going into catchability and how that could be adjusted.
Yep, thank you.
Yeah, I recall we had quite a bit of discussion about this hook competition model in one of the early SRB meetings. I think it was stretched over a couple of meetings. And there are links to other publications on the topic. You can try to dig up.
That's right. And I should point out, we're not the only people, I believe, doing this, and it has been published by, the methods have been published by other authors who developed something similar in parallel with us.
Kim, do you have any questions at this point?
I do not, thank you.
Sven?
Just wanted to check to what degree the unavailability of the data is usual versus COVID related.
It's entirely usual. This is, it's generally at the end of the month, maybe first few days of October some years, that we get the data locked down from the survey. So with in particular this year, the weight data, with the direct weights, it's only the second year of doing that. We're still some methods, I guess, being worked out, but last year there were a lot of errors in that data source. You know, the weights 1,000 times what you'd expect them to be, or the weights recorded in kilograms instead of pounds, and so on. They've worked out methods. They've worked out some ways that avoid that at the data entry level using the tablets on the vessels. But there's still some things that need to be ironed out before I can leap ahead and start even preliminary modeling of those data. So this is what you can continue to expect in the future. We have a lot of data, and it does require quite a bit of quality control and processing before we get hold of it.
Yeah, I was just thinking in terms of making decisions on the 2021 survey plan. I don't know what point you would have the 2020 data, because otherwise you're modeling essentially 2 years into the future, and what's the future potential, at least, of shortening that to 1 year into the future?
So this is going to be addressed in my second presentation.
Okay.
But my hope is that it's the June meeting that, yeah, we will be a 1 year lag essentially in terms of the data. That the June meeting will be the meeting in which you get the proposal for the coming 3 years, and you would have to make your decision on endorsing that. Well, it would be ideal if decisions on endorsing that could be made at the June meeting, because there really isn't a lot more that's going to be added prior to this meeting in a typical year.
Okay, thanks.
Yeah.
So I think I have kind of a related question, but I think it's coming. I think it's coming in your next presentation. So I'll wait until that's done. Let's see if that answers any questions I have. Okay. So yeah, feel free to move on to 4.2.
Okay. Okay, so this is a shortened version of the presentation that I provided in June, noting that we see at the end, we're hoping for an endorsement at least of the 2021 proposal, which we got a sort of qualified statement of general support, I guess, in June, but we're hoping for an endorsement. So we're going through this. Most of this material is new, but I've added some. Sorry, most of this material you've seen previously. There are a couple of new slides with some. Well, we'll see those when we come to them. Okay, so summary. Again, we were going to revisit the background of the history of the FIS briefly, the expansions that we've just finished, space-time modeling, the design objectives, and the review process. And that part, for the most part, we saw in June. The proposed designs for 2021 to 23, you also saw in June, but we've done a little more on evaluation of those designs and some discussion of consideration of cost, which we, even as scientists, we have to consider when we're developing these designs. So the FIS, our most important data source on Pacific halibut, comes from our own setline survey. It provides data for estimating weight and numbers per unit effort, indices of density and abundance, which we use to estimate stock trends, stock distribution, and as an important input to the IPHC stock assessment. And they provide biological data for use in the stock assessment, ages and weights and lengths and so on. Standardized FIS has been conducted every year since 1993, standardized for bait and fishing gear in particular. From 1993 to 1997, spatial coverage was limited and generally restricted to the core areas 2B, 2C, 3A, and 3B. And sometimes not all of those were fished every year, and sometimes only parts of those were fished in a given year in those 4 years. The modern design began in 1998 with a 10 nautical mile grid, stations on a grid 10 nautical mile spacing between the grid lines. And by 2001, annual coverage occurred in all IPHC regulatory areas until 2019. And this is the first year that we haven't had that since then. Depth range on the original design was 20 to 275 fathoms. It's assumed that there was no appreciable halibut outside of those depths at the time. And that's in the Gulf of Alaska and the Aleutian Islands, and 75 to 275 fathoms along the Bering Sea shelf edge, where there are huge shallow areas that would be impossible for us to undertake a survey on a 10 nautical mile grid every year. So by 2010, the data from other sources had showed that not all Pacific halibut habitat was covered by the FIS. And Pacific halibut in particular were present outside the depth range in both deep and shallow waters, in some areas in particular. And all regulatory areas had coverage gaps even within the standard depth range. And such unsampled habitat meant there was potential for bias in estimates derived from the FIS data. And this led us to propose expanding the coverage to include that unsurveyed habitat. So we did a couple of pilot expansions in 2011 and 2013 in regulatory area 2A. In 2011 was our first test of fishing in deeper and shallower waters. We went to depths of 400 fathoms in the deeper waters and up to 10 fathoms in the shallower waters. Shallower than that, it becomes difficult to fish the long line gear that we use. And from 2014 to 19, we had a planned program expansions in all regulatory areas. And you've seen this before. These numbers before, a substantial increase in stations in almost all regulatory areas, particularly in 2A, 4A, and 4CDE, and 4B, and 2B. So during the expansions, we occupied for the first time 34% of the full 10 nautical mile grid that had previously been unsampled. So that 1,890 station number I mentioned before, 34% of that was new after 2011. And the result was an improved understanding of Pacific halibut density and distribution. Bias was reduced, with indices for several regulatory areas being revised upwards or downwards when the new information was added. Uncertainty in estimates was reduced in most regulatory areas because previously within the space-time model, we had to use covariate relationships or spatial associations, which were often quite weak as you moved further away from actual observations to estimate those areas without direct observations. And these improvements were apparent throughout the time series, not only in the year of the expansion. The resulting 1890 station grid has provided a full FIS design from which stations can be selected for sampling in each annual FIS. And as I mentioned, 2020 was the first time in which we made use of that 1,890 station grid and not some reduced version of that. And this is what the full grid looks like with a couple of additions. So the orange stations here are our full 1,890 station FIS grid from Northern California out to the Russian EEZ line and the Aleutian Islands and the Bering Sea shelf edge. And so it doesn't look like we have no coverage in other parts of Pacific halibut habitat. We note that each year we use NIMS Bering Sea Troll Survey data, indicated by the blue dots there, and the Alaska Department of Fish and Game Norton Sound Troll Survey data to augment our own survey in the Bering Sea, the Eastern Bering Sea. And that's via a calibration between the two surveys, the NIMS and our own survey, and some scaling adjustments for the Alaska Department of Fish and Game Troll Survey. And as mentioned, the only data source in the Bering Sea this year, in that part of the main part of the Bering Sea, not any part of the Bering Sea actually, are the red dots in the far northeast in Norton Sound. So we do have a little bit of information on the Bering Sea, but not much compared to what we usually have. Space-time modeling has been used since 2016 to produce the weight per unit effort and numbers per unit effort estimates. It has two key purposes: smooth the data in time and space, and fills in gaps in survey coverage using model predictions while accounting for uncertainty. Noting that before we were using the space-time modeling, these gaps were previously filled in quite an unsatisfying way using ad hoc scaling factors based on ratio of averages in surveyed and unsurveyed habitat. And these things were constantly being updated each year or fading into irrelevance as time would proceed since the last time we had some of these gaps filled, and sometimes the gaps had never been surveyed in the first place. So this was a substantial improvement. We've noted that you have endorsed the space-time modeling approach as an improvement over what we've been doing previously, and that as Olaf noted earlier, the space-time modeling methods have been published in peer-reviewed journal earlier this year in the Canadian Journal of Fisheries and Aquatic Sciences, and we've just had another paper accepted where the space-time model methods were used for modeling Pacific halibut larval data in the Bering Sea, and that's been accepted for fishery, Josep can correct me, Fisheries Oceanography journal, so that's two. And it's worth pointing out that these are not unique to us. These are pretty standard methods now, and that are quite widely used for modeling, not just fisheries data, but all manner of ecological data. So,
Ray, sorry.
Yes.
Go ahead. Just to clarify, the space-time modeling generally doesn't use the exact same method as you do, or the same covariates or anything like that. So I think endorsing the space-time approach is different from saying from endorsing the model. So I was just trying to seek clarification of whether this is so standard that everybody uses the same system and for the same purpose, or whether it's just the modeling aspects of a space-time continuity, the space-time model that you're talking about.
I'm not going to speak for this previous scientific review board endorsements, but I'm referring to the use of space-time methodology in general. In particular, the geostatistical type approach that we're using is very widely used. It's what is used within the VAST modeling led by Jim Thorson, and where you the specific covariate model will vary depending on what you need from the data, and the structure of the spatial correlation will vary. The links between the data and the latent model will vary as well. But the general framework of geostatistical spatiotemporal modeling is widely used in fisheries and other ecological applications.
Ray, I would just add that it's certainly widely used in the academic context, but I think the use here as part of a routine survey analysis tool is something that, at least in the U.S., in the NOAA surveys, is quite unusual. Most of those are still based on ratified random design-based analysis, and it's a huge constraint for those for analysis of those surveys. So this is really innovative in many ways as well, even though the methods are standard and reliable.
Thank you. I appreciate that clarification, because I tend to forget that sometimes because I'm in my own little world and of using these methods, and I've been exposed to these for at least 20 odd years. They're nothing new in the world of statistics. While the methods themselves have evolved, the computational methods have evolved and become easier to use for statisticians. They're not anything new otherwise. But so thank you. Okay, so we developed and presented it. This one slide's gotten quite messed up. We developed earlier in the year sampling priorities, and corresponding design elements that we are using to guide us in our can use to guide us in decisions regarding this survey. So we start with the primary objectives. Primary priority, which has the objective of sampling the halibut stock for assessment and stock distribution estimation. This is our scientific objective. It's above everything else, getting good data for the assessment and stock distribution estimation. And so we'll have minimum sampling requirements in terms of station distribution, station count, and skates per station. However, we have other considerations, in particular, the secondary consideration of long-term revenue neutrality of the survey. It means we have to account for the logistics and costs. The survey has to be operationally feasible, and we can't lose money or make large bags of money on this survey. That's not our intention. And then we have other considerations, such as minimizing the impact on the stock of our survey. So essentially, don't catch more fish than we need. Assist others to collect data on a cost recovery basis. So our surveys use as a platform for other agencies for information that they need, and implementing IPHC policies, and that can be through ad hoc decisions that the Commission make regarding the design that are not necessarily related to logistics and cost or our primary scientific goals. So based on these objectives, we've developed methods for evaluating potential future FIST designs and presented proposed designs for review. And you reviewed those methods, at SRB017 and SRB016 in June this year and last year. And design proposals for 2020 to 2022 were presented at the previous interim and annual meetings. In an annual meeting 96 earlier this year in February, commissioners adopted an enhanced version of one of the proposed designs. And those evaluation methods we'll be touching on. We'll be looking at a bit more later in the presentation, not necessarily in detail, but the results, output of some of that evaluation for the coming year's designs. So the review process, Sven brought up earlier the question of when the data become available, and so this is an evolving process. This is the first year full year that we've been working with the design based on these methods following the expansions. And so last year was certainly figuring things out as we went along to some degree. And so what we hope to be able to do is get a structure, a timeline for how this proceeds now and in the future. So we know what to expect and what to expect from us. So following the completion of the coastwide expansion efforts, 2019 and 20 was the first year of fully rationalized designs could be proposed. By that I mean designs based on the full grid. And beginning in 2020, it's expected that the design proposal and review process going forward will be as follows. That we will present design proposals to the SRB for 3 subsequent years at the June meeting. And we did this in 2021, for 2021 to 2023 in June. And my hope is that going forward, you'll be able to endorse those designs or suggest changes or whatever at that June meeting. And that'll be kind of a, yeah, anyway. So the first review of design proposals by commissioners will be at the September work meeting, revised if necessary based on your input at the June meeting. And that has been completed for 2021 to 2023. And then we'll present the proposed designs at the November interim meeting. And the designs will be presented and potentially modified as they were in February this year at the annual meeting, given commissioner direction. And then the adopted designs for current year will be modified potentially for cost and logistical reasons prior to the summer implementation in the FIS. And we're hoping that we can head off some of that last step. Ian has developed a nice Excel spreadsheet tool for getting a handle on potential costs of potential designs in advance of interim and annual meetings, which we didn't have last year. And so hopefully we don't have the same scope for changing the design so much following the annual meeting as occurred this year. Again, we cannot predict things like pandemics that, or other drastic changes, but in a typical year, hopefully we can have what comes out of the annual meeting is essentially what gets implemented in the summer. So I put together this timeline to try and summarize that annual process, and I've started in March following the annual meeting with my work developing and revising the FIS designs for the next 3 years based on what I understand the design to be in the current year. That's going to be implemented in the summer that's approaching, and now with the data in hand from the previous year. So I've broken this into a review part and an analysis part, the review along the top and the analysis down the bottom. And then the next step would be an SRB review in June, where we will recommend that you endorse the designs that we're proposing, but where you may instead, or in addition, suggest further work needs to be done before you see us again in September. And then the work meeting review takes place near the middle of September, and the FIS data will be finalized in round about the end of September, beginning of October. Then the modeling, the space-time modeling will take place over the month of October. And as part of the evaluation of the modeling, as I mentioned in a moment, we'll be able to compare projected and estimated coefficients of variation. One of the things we can do to see whether our projections of how the future surveys are expected to perform tallies with what we actually get when we get the data. The interim meeting will undertake their review in November, and then the annual meeting decision will be made at the end of January, beginning of February, and then the cycle starts all over again. So I might pause there, and because this is a new slide, to see if there's any other any questions about this particular this formulation of the timeline. Before I do that, we had the work the commissioners suggested, noting somewhere that the designs we propose will be discussed with industry at some point, and that happens routinely as part of scoping out charter vessels for bids. Otherwise, I'm not entirely sure where to put that in there or how much input we really want, given that these designs are meant to have a scientific basis and be fishery independent. But that's just a little note based on last week's meeting. So I just wonder if there's any questions on this, or we could circle back to it.
Ray, this is Sean. This does address the question I had before. So the idea here is to develop a 3-year or designs for 3 years. So is this going to be done every year so that the 3-year designs are constantly being changed, or are you going to propose 3 years of designs and then come back 3 years later and start this? So is this an every 3-year process, or is this every year?
Every year. So each time we get data, the intention is not to lock 3 years down. It's to have the 3 years we're proposing, so we have some predictability in what we're going to do coming in the future.
Okay.
But each year we get new data in that could impact our priorities or impact our understanding of variability or understanding of stock distribution. And so it would makes the most sense that we would revise the subsequent 2 years as part of the next year's 3-year design.
Yeah, I mean,
there's a potential
it makes
for that
no sense to have it
year.
fixed.
What's that?
Yeah, I mean, there's no advantage to having this fixed.
No,
3 years.
there is not.
So yeah,
you start to lose. You can lose track of things if suddenly you see the fish appear to be somewhere else. We got some new information, or our CVs are blowing up faster than we expected. Then you know, there's no reason to stop us from modifying the design in subsequent years.
Yeah, thanks. Olaf, do you have any questions?
No.
Kim?
You mentioned some of the Commission's recommendations. Could you just go over how the implementation of this process reflects their recommendations, recommendations 1 and 2?
What are recommendations 1 and 2? I'm sorry, I don't have.
Okay, so the space-time modeling, the Commission recommended that the Secretariat employ a proposed sub-area design for some areas, an enhanced random sampling design for other areas. So it's sort of a hybrid recommendation for sort of a hybrid model.
They're recommending our proposed design, as
that's a proposed design. Okay.
Yeah. We proposed that, and you'll see that very shortly. So that I apologize, I haven't actually seen that report, but that sounds like our proposed design that we presented to you in June and to them last week.
And it also, the second one was incorporating tertiary objectives associated with, I'm assuming this is taking advantage of other collaborators. They mentioned specifically Washington Department of Fish and Wildlife and DFO Canada as part of their rockfish sampling. It's
With something that we discussed at the meeting.
17.4.
I'm a little, is this, Ian might want to jump in here, but this may be related to a discussion one or two commissioners had about some of the other surveys that are being undertaken, and maybe we could, okay, this is, no, I went back a step. I'm pretty sure that this is just what we do routinely anyway, that this is one of our tertiary objectives. It's them taking advantage of our platform so that they're providing us with some funding or something so that we can sample rockfish in off the coast of Washington, and then we can sample yellow eye or whatever it is they ask us to do in British Columbia. Ian might want to clarify that.
Yeah, would just add that these are essentially add-ons that don't cost us. They're not a cost to our scientific design, although they may cause some cost on the water. Often they result in some to a few extra stations that we wouldn't normally have fished, but we can still use the data from. But I don't think in any case have our tertiary objectives actually been reduced the scientific integrity of our design. If anything, they just add and provide vessels of opportunity for other projects that might be going on.
Thank you, Ian.
Okay, yeah, I mean, I was just looking at the SRB017-04 document, the appendix, which was excerpts from the annual meeting, and I was just curious about how these recommendations and requests were, fitting into this planning process.
Okay, so that was the annual meeting document. I understand now. Yes, so the recommendation, first, if that's the annual meeting document, that first recommendation that you mentioned was them recommending whatever the hybrid survey design was, that was an enhanced version of the proposed design. And the other one is just them recommending we do what we always do regarding using our survey as a platform for other agencies.
Okay.
Sven, do you have any comments or questions at this point?
I think it's answered some of the questions. It still seems I guess it would help to make it clearer which part belongs to which, because there's really two processes going on in parallel, or one before the other because of this time lag. So it would be helpful to have that clarified on here, because the first time of reading it, you follow it and it seems like it's no lag, but because of the way the survey data becomes available, it becomes the lag. So it's just some clarification of that would be useful. And the other thing I wanted to ask is, you have as a criterion for going forward, compare projected and estimated CVs. Is that the only criteria you're going to employ?
No, that is no, not at all. That is a way of assessing whether our evaluation of proposed designs is doing what we expect it to do, and it's something that I know you've been discussing. I believe you have a concern that we may be underestimating by using samples generated from the last year's space-time modeling as data for projecting into the variability into the future. We may be underestimating the variability, and so this will allow us to ground truth that. We will be able to compare what we actually estimate for the CVs and see if they are close to what our projections were. Are we being too optimistic, perhaps, is the concern in our projections going forwards. So that's something, I put that in there because that's the point at which we're able to do that comparison. Well, as soon as the modeling is undertaken, we can make that comparison. And there's another slide on that coming up.
Okay.
Okay, let's keep going.
So proposed designs for 2021 to 23. Again, this is still review. Due to budgetary constraints and the impact of COVID-19, neither the proposed nor adopted AEM96 designs were implemented in 2020. Instead, sampling was only conducted within the core areas, as you saw the map earlier. Because of this, our proposal for 2021 to 2023 was to shift the 2020-22 proposal, which we called a compromise proposal. You'll see it in a moment, compromise between random sampling and sampling sub-areas, which was presented at AM96, instead be implemented in 2021 to 23. This is, with the design being uncertain for the 2020 FIS, we had to come up with something quite quickly, as we discussed in June. And this design had already been evaluated. But as you noted in your, well, that's coming up. I'll come to that when I, oh, maybe I took that out. But as you noted in your report at the last meeting, because the evaluation was done for 2020 to 2022, this may not be the best design for the next 3 years. We know it's been evaluated, but it may be we can do better if we were to evaluate it formally. And you'll see results of that evaluation using the metrics, or at least one of the metrics we discussed at the last 2 June meetings coming up. So this design uses the efficient sub-area sampling at the ends of the stock and incorporates a randomized design in the other areas. And it's likely that this design represents the maximum effort that can be deployed outside the core areas in coming years while still meeting the secondary objective. So this is like a note of realism. We can, I would love to be able to do randomized, fully randomized designs in 4A, 4B, 4CD, and 2A every year. That's not realistic, given the current state of the stock, the current prices of halibut, and our goal of revenue neutrality. So it's unlikely we're going to be able to do designs of greater spatial extent in those areas outside the core where we're losing money in doing the survey than what we are proposing here. That doesn't mean we can't adjust the design, doesn't mean we can't propose something else, but it's likely to be unrealistic. And this was the proposed design for 2021, which was our original 2020 design. And so in the areas 2B, 2C, 3A, and 3B, we have a completely randomized subsample of stations at sampling rates somewhere between 50 and 55%. With the exception of the inside waters of 2B, which we had almost no fish the one time we sampled it, and we do not need to sample this with great frequency unless some new information says otherwise. And so in 2A, 4A, 4B, and 4CDE, we have essentially a sub-area design. And 4CDE, we haven't actually devised formal sub-areas for this because our recommendation has been to sample all stations on the FIS grid in 4CD for the next 3 years. Something we went into some detail, the reasoning for at the last couple of meetings. In 4A and 4B and 2A, we are prioritizing those areas with the highest density that comprise the overwhelming greater part of the stock, and also possibly the greatest variability. The sub area is most likely to change from 1 year to the next or over short time periods. For example, in 4A and 4B, we've estimated that something like 70 to 80% of the stock is in those areas we're targeting for 2021 sampling, and similarly in 2A. But from 1 year to the next, we will potentially change the design. But note that the sub-area design, switching from 2021 to 2022, the sub-area design in those outside areas is the same. The reason is that these areas outside the sub-areas are still expected over a short time period not to change by a lot. They're either relatively stable over a shorter time frames at least, and so therefore they'll also expected to contribute relatively little to the smaller part of the stock from the areas we're sampling. But the randomized design does change. All those stations we didn't sample in core areas in 2021 will be sampled in 2022, plus some extras to meet whatever target sampling rate we had. 2023, we start with a complete new randomization in the core areas. think. You'll see some changes in the outside areas. We now are fishing the areas in 4B that we hadn't fished previously. We've added a sub area to 4A that wasn't in the previous 2 years. 2A is unchanged. Those areas that are yet to be fished as part of this design, this area here in 4A and these parts of 2A, would move into the design in the next 1, 2, or 3 years. And some areas are really low density, like the inside waters, we may not need to sample more than every 10 years. Okay, we talked about projected CVs. So as part of the evaluation of the evaluation, essentially, we compare the evaluation methods. We can compare the CVs that we estimate with those that, this isn't that slide, but we can compare those with that we predict. But for our evaluation, we are projecting CVs going forwards for the next 3 years. We want to maintain the coefficient of variation within a target. And the target we proposed was 15% per regulatory area. It's a target that we have maintained, we believe we've maintained, according to the estimates we got from the space-time model, and prior to that, to the estimates we had from the more design-based approach for estimation, that we've been within those targets almost all of the time in all regulatory areas, with a few exceptions. And so the proposed designs have high sampling rates within regulatory areas 2B, 2C, 3A, 3B, and 4CDE. So the CVs will remain within those targets with the designs that we've proposed. The randomized or full sampling designs in these areas will also result in unbiased estimation because it's full sampling or randomization. There's no room for bias based on this because of the survey design to come into the estimation. In the other regulatory areas, the other 3 regulatory areas, we project the following CVs as a percentage following completion of the 2023 FIS. So 2020 is not the value that we get in 2020 itself. It's the value we get after adding 3 subsequent years worth of data. So after completion of the 3-year set of 3-year proposals, what will the CVs look like? And they'll look pretty good. We can't fully claw back what we lost this year and get those under target, even with 3 years more data. But we can get back on track in the next 3 years by going back to the proposals that we presented last year and are proposing again in this year. So CVs now become within or on target in all 3 of these regulatory areas if we follow the design proposal that we've just presented. Now, bias. So as discussed at the previous 2 June meetings, we're proposing to minimize bias that might creep in by not sampling parts of the stock in these 3 areas in particular, but more generally, if we're leaving out sub areas each year, we aim to select a sampling frequency in order to keep the change of biomass proportion of each sub area within 10% between successive sampling years. So we looked at the proportion of biomass in each of the sub areas, and we're trying to sample frequently enough that change in proportion for all sub areas remains small. And if that change in proportion remains small, then the bias will also remain small. And this is based on estimated changes in weight per unit effort over the 1993 to 2019 period. So it's based on the historical time series, looking at how quickly did these sub areas, given that most of them have been sampled most years, at least to some degree, how quickly did they change in the past? And that's quite a long period to see changes over. So hopefully encompasses a wide range of environmental regimes, a wide range of stock sizes, and so on. So for example, if an area's percentage of its reg area's biomass, sub-area's percentage of its reg area's biomass changed by no more than 8% over 1 or 2 years, but by 12% over 3 years, we should sample at least every 3 years. So looking at the historical series, if we have a sub area that seemed to be relatively stable over a 1 or 2 year period, but by the time you've left it for 3 years, the stock has the proportions among the sub areas have changed to the point where this one now occupies a greater proportion of the stock, then history tells us we should sample that at least every 3 years. And so this table here basically summarizes that history. So the maximum expected change in biomass percentage across all sub areas since previous sampling based on the proposed designs and no sampling in 2020. So in 2A in 2020, we did not sample any sub areas, but we sampled parts of all the sub areas in 2019. So it's been 1 year since we sampled the sub areas. Based on history, we don't expect any sub area to be to have changed by more than 8% in terms of its proportion of the biomass, okay, in 1 year. Now, in 2021, we're proposing to sample one of the sub areas in 2A, the most dense sub area, but the other sub areas are relatively stable based on history of the stock. And so we still expect to maintain no more than an 8% change since the last time we sampled it. Likewise, in 2022, we don't expect to see a greater than 8% change in the proportion of biomass occupied by the sub areas that we're not sampling in 2022 since the last time we sampled them in 2019. It's not till we get to 2023 that we start to expect to see changes that tell us we should go back and sample some of those areas. Okay, so we're still at the target in 2023, suggesting we could sample them if we wanted to, but we don't have to maintain this target until 2024. Likewise in 4A.
For a second?
Oh yeah, sure.
Yeah.
Yep.
So is this just caused by the increasing range of uncertainty in these projections? Like what would cause?
No, it's caused by the changes in, this is not very sophisticated. It's changes in the estimates, the point estimates from year to year. So
you're kind of bootstrapping the point estimates from year to year?
Not even doing that. No, we're just using the actual sample of what is it, 27 years or something. So what do we see in those 27 years? Over the course of 27 years.
Oh, okay. All right. So this really isn't. This isn't these, right? So this is just like T+1, T+2, T+3.
That's right. And over the entire course of the time series, we didn't see T+4 for these sub areas that are not sampled, changed by more than 10%. Okay, we didn't see a change in more than 10% in from 1 year to 4 years subsequent.
Okay, no, I think I get it now.
Yeah, this is I think these are detailed in the appendix. Maybe I don't know what version of the paper this we submitted for this one, but certainly in the appendix for the June meeting, they were presented at the June meeting last year, where I showed you essentially the data on which these numbers are based, a version of it anyway, how much change we get from 1 year to the next for different sub areas.
Ray, can I jump in with a related question?
Yes.
I'm just having trouble conceptually understanding why it would make sense to sample the same areas, the same sub areas of 2A, 4A, and 4B 2 years in a row when the temporal autocorrelation is so high. Basically, and this is kind of showing it, right? Basically sampling the same part of the same sub areas 2 years in a row. It's not going to tell you very much. So is that just for achieving the cost goals?
No, it's in case something has changed and we don't want to miss it. If the stock is going up or down, you can still have high correlation. The stations might be consistent from 1 year to the next, but you might have an increase in the stock or a decrease in the stock. And by sampling where the bulk of the stock is, we're less likely to have bias by missing those changes from one year to the next. So the correlation isn't just that we get the same estimate from one year to the next, it's that things move consistently from one year to the next. So if one station goes up, you expect the other stations to go up. It doesn't mean that you have stability. So we still need to sample the stock to be able to estimate a trend. And by targeting these particular sub areas every year for annual sampling, at least until we see some distributional change that tells us to do otherwise, we'll be able to get at that trend from one year to the next.
Okay, so those sub areas are the ones that are the highest densities, and so the best sort of area to index that whole regulatory area.
That's absolutely correct. They're generally the highest density. They also change, and partly because of that, they're more likely to change by a large amount in terms of proportion from one year to the next. If you have one area that's close to zero and then this area suddenly drops, this proportion is going to, and this high density area drops, this proportion is going to change while the other one still stays close to zero. If we were just basing it on how frequently they change in terms of proportion of biomass, they could be sampled less frequently. But because they're indexing, essentially doing the work of indexing the entire stock in that regulatory area,
right.
We need to sample them annually. And what was I going to say? I had another point related to that, but I think you get it.
Yeah. I do. Thank you.
Yeah. Okay, so based on that, we're doing all right in our 2021 to 2023 survey. But you did mention, you made the wise, cautious note in your report that this design, this 2021 to 2023 design, may not be optimal, given that until I did this evaluation, it had only been evaluated for use in 2020 to 2022. And so one figure pops out here where we're not meeting that 10% threshold, and that's 2022 in 4B. And so it's a little bit above. That's not a great concern, but if we're going to have the threshold, maybe we should consider doing something different, because we do come back to meeting it in 2023. The proposal is in 4B, let's go back up. In 2021, we're only sampling the most dense area here in 4B in the east. And we do that in 2022. But the historical time series tells us that this western area here can be quite variable from year to year. And that was okay when it was, so that we should sample it every 3 to 4 years at least. Okay. So that was okay when we proposed that in 2020. It was going to be that in 2022, we were going to sample that. By pushing it a year ahead, that means that this is pushed beyond the 3 years that history tells us we should be sampling. It's not a great concern. It means that it's because it's still only going to be 14%, potentially up to 14% out, and that doesn't happen every year. This is the most we've seen in the historical time series, that changing over a 3 or whatever year period. So it's still unlikely to be as much as that. But if we're following this evaluation procedure, one possibility is that in 2022, we bring forward that component of the design and sample it instead of under a proposal that we put forward in 2020. At the June meeting and now. So that's something to bear in mind when you're writing your report as well. But again, why another reason this doesn't concern me greatly is that essentially the designs for 2022 and 2023 are provisional and will be reevaluated, as I noted earlier, when the 2020 data have been compiled. Okay, so we'll get another look at that next year anyway. So the annual revision of FIS design proposals. Speaking of that, as new FIS data come in each year, we revise our understanding of the spatial distribution of Pacific halibut. Local contraction or expansion of the distribution or changes in interannual variability in subareas can lead to revisions in the future frequency of FIS sampling in each subarea that will be incorporated into subsequent design proposals. We're not locking in things in stone. it would be unwise to do that, even on a 3-year basis. We should make use of the best information we have, as that may revise our understanding and lead us to propose revisions to the designs going forward. Now, projected CVs, the little arrow sticking at the end of October, I think, on the timeline. So the concern was, and it's a valid concern, that by using data that essentially are generated from the model as our samples for projecting the future, evaluating future designs, maybe we're underestimating variability. If there's something structural in the model that isn't capturing all the variability. So the comparison we can make once we've completed the 2020 design is to compare these projected CVs, which we have for the core area, which I've calculated for the core areas for 2020. We didn't do sampling elsewhere. And compare them with the realized CVs once we have the output from the space-time model. So for 032 weight per unit effort, we've projected CVs of 6% in 2B and 2C, 4% in 3A, and 10% in 3B. In 3B, we did a much more reduced design spatially than in past years. And in the other areas, we essentially sampled close to 100% in 2C and 3A, and essentially 100% in most of 2B. Plus, oh no, this doesn't account for the snap gear expansion in 2B. So these ones are to be determined, but once I've done the modeling, I can compare them. Are these understating? I guess the main concern is, are these understating our expected uncertainty in the future designs? And in this case, the future design was the 2020 design. So I think I'll pause there because these are the new slides. This is the new material to see if there are any questions, or if there isn't much left, but if might be helpful to talk about these while they're fresh in people's minds.
Does anybody have any questions? Olaf, your mic is on. Do you have a...
Sure, I'll just jump in, Ray, and I think this was really helpful. I think you've explained it well, and I think you've justified it well. My only question, and this is from not understanding the model that well, is how much the depth covariates matter. You know, as we look at a year like 2020 where we have a lot less data, we're relying on the covariates and the spatial and temporal autocorrelation a lot more. And is there any sense that the depth covariates matter a lot? And if so, have they changed through time?
That's a good question. Thank you, Olaf. I think that is, I'm not sure if we discussed that in June or not. It's something that I believe I was going to look at, but haven't yet. And that is, do the depth covariates change as we add more data each year? And I can't answer that off the top of my head because I haven't looked at those closely. But that's something I can look at least for the last few years before the end of the meeting. So I can possibly get back to you on that. How important are they? Relative to other sources, again, I'm not entirely sure either. We include them because there are clear relationships with depth. So our goal is to improve prediction in those unsurveyed depths. The primary goal initially was to improve prediction in the depths that we weren't surveying on an annual basis, the shallow depths and the deeper waters. And so they were often the only anchor that we had for making those predictions. But in the case where we have no data at all, what difference are those making? My feeling is that it's mainly the temporal correlation, although there's some other that's probably dominating things here. For the estimates that we're getting in 2020 that you saw previously. I would have to do some model fits just with and without these covariates, which is something I haven't done. Without depth in particular, I haven't fitted models with and without those covariates to see what effect they would have on the output. We have some other covariates in there. In some regulatory areas, regulatory area 2A, we have a covariate for north and south of 40 degrees north. 40 degrees north is kind of the southern limit of halibut. We've caught 2 halibut on an expanded survey in 2017 in 2A south of 40 degrees north. And so to ensure that the based on model estimates for that particular part of 2A don't just start drifting off towards the mean, or the mean given depth covariates, we put in a covariate for north and south, so it helps keep that estimate low based on the 1 or 2 years we sampled it. In 2B, we have a covariate for the Salish Sea, the inside waters. Again, it's an area of very low density that we sampled once, and so it doesn't, otherwise, without something in there to anchor it, it will start to drift over time towards the mean on the transformed scale within the space-time model. And there's another covariate in 4CD for the distance recommended by the SRB, distance from the shelf edge, as density generally decreases with increasing distance from the shelf edge. Those ones have been checked to see whether they improve the fit of the model, including them or excluding them, and they all improve the fit of the model markedly. But that's a different question, asking whether they make a difference on the estimates that come out of the model themselves.
Right, and they could be improving the fit of the model overall while not necessarily being consistent through time, right? I mean, they're treated in the model as being consistent through time.
Yep. In the case of the a couple of those covariates I mentioned where we only sampled once, there's no information on changes in time. But in the case of depth, yes, it's something we could look at. And I recall us discussing it at some point, and or at least there were questions about how do these parameters change as we add data. So that's something I can look at, because we do have them now from 2016 onwards. But bearing in mind that the first time we fitted this in 2016, we already had data from 1993 to 2016. So you would expect changes to be relatively small as you add new data, because that data is a small fraction of the overall time series. With the exception of when we did an expansion into deeper or shallower waters for the first time, and then we finally anchored that part of the relationship. So maybe not so small for part of the curve. But thank you. That's a useful reminder for me to review that information and put that in my next presentation to you.
Great, thanks, Ray.
Hey, Ray.
Hi.
Thank you. Would you also be able to present to us, I mean, I know you're talking about the parameters here specifically, or the values for the parameters, but just, I guess, when you've done the projections using the 2020 data, right?
Yep.
You can go back to the previous model and use the projections for 2019 from those two models and actually compare what's changed in the model to give an overall view, right?
So in this case, you're not talking about estimates like the right-hand column here. You're talking simply about projections. What did we project for a year like 2022? Based on made up data or whatever data generated by the model, or then what do we project if we put the real 2020 data in there?
No, that's not what I meant. Is in order to see how the parameters changed, you can do by looking at the parameter, but you'd have to go for the 2019 estimate from the two models that you have and actually compare the actual predictions for each station, or ideally spatially in a map, to compare how it's changed its perceptions of what the abundance was in the previous year, in 2019. Do you see what I mean?
I think I'm going to try to clarify. So in 2019, we got estimates at each station, posterior means, whatever, at each station. In 2020, we will get new estimates for 2020, but also for 2019.
Yeah.
And we could see how those estimates have changed.
Yeah, compare the 2019 estimates from this year's model or the coming model, the final version of the model, compared to a retrospective analysis, essentially, but by station.
Right. Yeah, I mean, it's parsing out. It's parsing out. Oh, how far? Nope, wrong presentation. Those curves I showed you earlier of the comparison of the 2019 modeling with the 2020 modeling were the ones where we had no data. Essentially, you can see how those lines have changed in the terminal year in particular with the addition of data. But you're talking about at a more granular level, looking at the
station themselves. Whether there is changes in the parameters, such as the depth parameter, you would very quickly see that's what's changing, or whether it's an area change where one area model has changed compared to other area models, and those kinds of things give you a very quick overview of how the perception has changed, how stable that model is.
Yep, that's fair enough. What is driving the model more than anything else, of course, are the data. And so as we introduce new data, that's going to be the thing that probably I would expect to dominate the change. So if a patch of halibut has increased in density or suddenly decreased in density relative to the surrounding patches, that would revise our understanding from last year as well. We would see that go up or down relative to the rest of the stuff, regardless of whatever else is going on with the covariates.
Exactly. You'll see the scale of that pattern that you see.
Yep.
You'll see the scale of the divergence, and that will give you a good idea of what the model is doing. So that's kind of gives you a way of trying to assess how much those parameters are changing without looking at just the trend in that particular parameter orthogonal to across all the areas.
Okay. Yep. That's something I can look at and put in presentations for next June.
Yeah, I think to me it's one of the ones that I would try to want to see as a means of endorsing or otherwise that model quality control criteria, basically.
Right. You would be concerned if you were seeing great changes.
Yeah, if it was just flipping from one side to the other, every year was different, and it was just basically following data, then I would have concerns. But, that's what I'd like to see.
Sorry, if it was, why would you not want, I'm a bit confused. Why would you not want it to follow the data? That's what's driving everything.
No, I didn't say I didn't want it to follow the data. What I'm saying is if the model from one year changed its perception dramatically about what the thing was doing the previous year, then I would have concerns that it's basically just tracking data, and by that I mean it's tracking the variability in the data and interpreting as process.
Yep.
Rather than yeah. So
I misunderstood.
I think we're on the same page. Yeah. No.
We're on the same page. Yep. Yeah. That's fine. I got it. Thank you.
All right.
Okay.
Shall we press on?
Yep. There's not much left. So cost. I don't like to think about it, but I have no choice. The proposed FIS designs for 2021 to 2023 do already incorporate some consideration of cost. They used logistically efficient sub-area designs in lower density regulatory areas. And the goal here was to provide statistically efficient and logistically feasible designs for consideration by the Commission. I can produce these fantastic randomized designs with high sampling rates throughout the stock, and there's no point if I know they're going to be summarily rejected based on cost considerations or logistical considerations. And so the FIS is funded by sales of captured fish and is intended to have long-term revenue neutrality, our secondary objective, meaning that any design must also be evaluated in terms of the following factors: the expected catch of Pacific halibut, expected Pacific halibut sale price, charter vessel costs, bait costs, and the costs of staffing the vessels with our scientists. So balancing these factors may result in modifications to design proposals. We may need to increase sampling effort in high density regions and decrease in low density regions, which is essentially what we did to the extreme in 2020. And at present, with stocks near historic lows and low prices for fish sales, the current funding model may require that some low density habitat be omitted from the design entirely, as occurred this year. And this will have implications for data quality, particularly if such reductions in effort relative to proposed designs continue over multiple years. And this slide was presented in June also. It's kind of a warning that, yeah, we can do what we did in 2020 and still be okay. But if we continue to do fish a design like the one we did in 2020, there's going to be consequences for data quality. And the last slide. Okay, our recommendations are that you note the accompanying paper. And endorse, in particular, we're hoping for your endorsement of the final 2021 design proposal, the one that has to be implemented next year, and provisionally endorse the 2022 and 23 design proposals, recognizing that these will be reviewed again at subsequent SRB meetings. If there are any changes we want to make to those proposals, we can still make them in 2022, and there's a good chance what I'll be presenting to you in 2022 will look a little different than what I've presented here today for those 2 years. And that was the end of the presentation. So I guess if there are any more questions, I'll take those.
I have just a small editorial terminology issue on slide 19. You're using the term target here to represent the 15%. I believe what you mean there is a limit, because you're not actually aiming for 15%.
Fair enough.
Keep it below 15%, right?
Fair enough. That's a term we've been using the last 3 years.
Yeah.
2 years. Yep, and I appreciate that it's been
I
noticed.
just bring it up because the MSE group, I'm sure, is going to be talking about targets and limits and other things, and hopefully it's going to be used consistently across those. So
thank you. I will amend that for future presentations. I appreciate that.
all right, well, I really appreciated this document. That, you know, it was just in one place. It had a nice narrative about the entire design of the survey from the beginning to the present. So I thought it was really helpful, and I'm sure some of our newer SRB members really got a lot out of it. Do we have any other comments at this point? We have about 15 minutes until our next section.
Sean, this is Ian. Could I make a quick comment?
Sure.
I just want to note that we're sort of poking and prodding and trying to make, learn as much as we can about the design. And we've, in some cases, really highlighted where 2020 has been suboptimal. But taking a little slightly broader view of things, I think it might be worth noting, and perhaps you all would consider putting this in your report, that the IPHC managed to launch an amazingly successful survey in 2020, given all the conditions. I mean, we're looking at a projected CV of 10% or less for areas that represent approximately 70% of the biomass. So even though for us this was a triage year where we just did the bare minimum we could do, we still ended up with what I think is probably a better survey than many survey time series around the world. So I just wanted to throw that in there so that we don't necessarily just focus on the negative.
Totally.
I think that's a great.
Totally, yeah. And I don't know if you guys are part of that issue that came up in the work meeting where I think one of the commissioners had kind of, I don't know, mistakenly interpreted some of our earlier comments about things not being exactly optimal to mean not to a scientific standard. And so I think we have to continue to reinforce that this is above the scientific standard to begin with, and you're just kind of tweaking. So, but this is a really good point. Olaf, you were.
I was about to say the exact same thing. I mean, the in 2020 here where everything fell apart, you still have better CVs than the best years in most surveys that I'm used to dealing with. So, and just 2 weeks ago, I was talking with folks in the Northeast Fisheries Science Center about what to do because they have no surveys this year. So, I mean, the IPHC is in a very, very good position in terms of surveys. And I think it's because there's such a robust design here, and the spatiotemporal model allows for so much flexibility that that it can accommodate things like what happened here in 2020.
Was there anything particular that you guys learned this year about the logistics of this survey that kind of popped up in a crisis? I guess not.
I was wondering if Ian had anything to say. I haven't really heard much myself from the folks who undertook the survey this year.
Well, as of the work meeting, the survey was successfully COVID-free for the whole duration, both crew and scientists, which I think was our primary concern, even perhaps before the data. We had extensive quarantines and all the travel logistics and everything. And while there may be 1 or 2 people left just at the tail end of their 14-day quarantines, I think it's pretty important that the logistically our survey team got people out and back safely this year. It was a really good year for the survey team, noting that we have a fairly junior survey team in terms of their long-term experience with the commission. So they really pulled off a tough task this year.
I just wanted to say that it's quite variable throughout the world what people managed to get done, but it wasn't easy for anyone. So particularly with the junior set of staff, they ought to be congratulated.
Okay.
If we have a little bit more time here, the issue that Ray and I were talking about before about correcting for hook saturation and bait loss, it made me think about other factors that could be generating hyperstability or hyperdepletion in the index. And I was wondering whether there are other factors and whether they are dealt with exclusively at the level of the survey, or Ian, whether you also try to account for that within the assessment.
I'm sorry, Olaf, I lost a connection there for a second. I'm having a little internet trouble at my house.
Sorry, I was just asking about hyperstability and hyperdepletion in the index with respect to where it's corrected for in the survey or in the assessment.
Thanks. So I think the primary concern for longline surveys is gear saturation. And our approach is sort of twofold there. One is we try to deploy a considerable amount of gear at every station. We have a minimum of 400 hooks that need to be deployed at each station. Then the secondary approach, as Ray has laid out, is that we're using, as far as we know, the state-of-the-art method for correcting for hook competition and or gear saturation by enumerating the baits returned and essentially correcting for the latent fishing power available at the end of each fishing event. And I think that's important on two levels. One is that we're doing that on a station-by-station basis. That's evolved over time. We used to pool areas to do that, and now we're actually doing it on a station-by-station basis. And so that means that if we have small hotspots of gear saturation, we can account for that. And so I think that's an important improvement, rather than applying an average hook competition correction over a broad area where we might be inflating catch rates in some places where there actually wasn't competition and not doing it in others. And then I think the other point that I maybe Ray mentioned, but I might have missed it, is that these things also have long-term trends. So for example, the population of dogfish in the Northeast Pacific isn't necessarily stable over time. And so as that population comes and goes, we could have entire years when we have increased competition for hooks or decreased competition for hooks. And the way that we do this hook competition correction, it's standardized across the entire time series. So that way, if we have a decrease in competition that's global across all areas, that will actually affect the overall index for the year. So, to answer your question, we've corrected for the things that we know could be causing this issue, noting that any survey gear is subject to some degree of saturation and hyperstability at extremely high or extremely low catch rates.
That's great. Thanks, Ian. That sounds like a very sophisticated approach. Is this exponential decay model parameterized just through the baits remaining versus empty hooks, or have you used hook timers at some point to try to help with that?
It's just through the baits returning. That's the only piece of information that feeds into that. Ian probably can speak more about this than me. I believe we have done some hook timing studies in the past, but it's something that's come up for discussion again. But I'm going to turn that over to Ian because he is more onto that than me.
I'm sorry, once again, I'm having trouble with audio connection here. My internet at my house is out, now I'm on a hotspot. I hope this isn't going to cause a problem for the presentation. Could you state the question one more time?
I just asked Ian whether you've ever used hook timers to try to parameterize those decay curves for available baits, or whether you just do it with the remaining baits at the end of the set.
Thanks. As Ray noted, right now the correction only includes the baits back. We don't differentiate between empty hooks and hooks with other fish on them. We have historically, at least more than 20 years ago now, done some work with hook timers. At the time we did them, they were relatively large, and the technology was such that they didn't really meet our needs in terms of understanding what was going on. I think there's potential for renewed look at hook timers. One of the questions that we've received from our research advisory board this year, in fact, was with regard to the potential for different levels of competition or different types of competition from different species. Notably, potentially dogfish are midwater schooling fish at some times, and they may actually be competing for the gear before it's on the bottom or having priority access to the gear. And so in that regard, it would be nice to know whether or not we need to somehow treat them differently, because currently we assume that all competition for hooks is occurring simultaneously as opposed to having a priority order. So that is a potential research topic that we've identified, but not one that we currently have a specific plan to go out and test.
Thanks.
And your sets are relatively short as well.
How short are they?
Like 5 hours, or how long are they?
Yeah, our sets are a minimum of 5 hours and a maximum of 24 hours. But what we find is that the catch rates drop off substantially after 5 hours. We give the boat a window to be able to get back to that gear. But historical studies have shown that the number of fish that you get back on the gear essentially stops changing after about 5 hours. And we cut it off at 24 because at some point there's a potential for sand fleas and other species like sharks and things to start damaging the fish. And so the catch rate could actually start going down again at some point. So we don't just give them a totally open-ended period over which to fish the gear.
So between 5 and 24 hours, it's not corrected for time.
That's right. Historically we understand that the catch rate really doesn't vary much over that. If we were trying to include data less than 5 hours, we would expect a pretty rapid increase in the catch per unit effort over the first 5 hours, but it seems to saturate about there and not change much until we actually start to see fish coming back off the gear.
Yeah, great, thanks.
Sorry, Ian, just very quickly, you're applying the hook correction to the biomass estimate or to the numbers estimate?
I can answer that. It's both.
Oh, sorry.
It's weight per unit effort and numbers per unit effort. We apply the same hook correction to all indices that we get from the survey. So it's applied as part of the data processing before the data go into the space-time model. And we make that adjustment, as Ian said, on a station-by-station basis. So it's essentially part of the calculation of weight per unit effort or numbers per unit effort. But the adjustment's the same because it only depends on numbers of hooks, numbers of baits coming back, which doesn't have anything to do with how big the halibut were when they came back. And indeed, further than that, other people have been making use of our data to index other species for their own assessments, and the same adjustment applies to those species too.
It's not, I guess that's the correction factor you're talking about, but the competition level surely changes, or at least the competition from in terms of weight differs, right? If you have one large halibut and there's one hook left, you have a chance of catching it. If you have 5 small halibut, which are the same, you can only catch one of them. So you'd have to have a different correction for the biomass versus the numbers, right?
That silence is me thinking about this.
It doesn't matter. It was just an interesting idea that you were counting hooks, yet you're using a biomass index. So, but not to worry. I'm sure it doesn't. Have a think about it, and we can discuss it some other point.
Okay, well, we're just about time here to switch over to the stock assessment, which I assume looks like Ian is going to present from his phone or something.
Hopefully my connection's okay now, Sean. I would offer, my presentation is relatively short, so if we did want to take a break now, I'm sure that I'll finish it comfortably in the time slot allotted. So
I could use a break right now. I could use a break right now, actually. So when I propose this, that we break right now and we pick it back up at the top of the hour.
Oh, thanks. I'll be ready with my screen showing.
Okay, that'd be 3 p.m. Pacific time and whatever time that is for Savannah.
11.
Let's do that.
All right, I'll see you in a bit.
Come back in 17 minutes. Okay, bye.
On my phone, hotspot.
Yeah, sounds good.
Excellent. I'm ready to start whenever you are.
Okay, why don't we get started?
Okay, 3 o'clock. So I'm going to provide an update on the development of the 2020 stock assessment, and this is just the standard update that we do in September for the process. But I did want to take just a second to step outside this presentation for a second, and probably Sean is the only one that remembers that over the past 16 SRB meetings, we have occasionally provided a little break from the normal dry review with some scenes from the field. And I thought maybe this year, because probably none or very few of us have actually been in the field, that it might be nice to do that in this presentation as well. So bear with me for one slide. And here's a few scenes from the field over the last couple of years, probably since we did this sort of thing for the SRB. So I just pulled a few highlights photos here. Clockwise from the top left, we've got what port sampling in Kodiak looks like. That's in fact 37 bald eagles watching our port sampler collect his fish on the dock. We've got in the top center, we've got the Southern Seas, which is pretty typical longliner for Alaskan waters, not big boats. And these guys fish all the way to the end of the Aleutians, where they are actually farther from Anchorage than they are from Hawaii. On the top right, we've got the 500-pounder that came in this year. That's actually a 499-pound fish that was caught in Kodiak. And I frequently get questions about where have all the big fish gone? How come there aren't any anymore? And the answer is they're still there. They're just more rare than they used to be. We see almost every year, and definitely every 2 to 3 years, we see a 500-pound fish caught somewhere in the stock distribution range. For reference, those are not small guys in the photo with that fish. Bottom right is the Polaris. This is a 100-year-old schooner that we chartered in 2020 to conduct our survey on. It really is as narrow as it looks. And I think we only have 2 scientists on board when that boat is out. And we've been using boats like that schooner for 100 years now as part of the IPHC's research. Bottom center there is a fish that somehow got confused or maybe hides vertically in the benthos. Because both sides of its tail turned out to be pigmented. We see a fascinating number of oddball fish, sinestral halibut, fish with strange pigmentation, all sorts of things every year, and it's always kind of fun to compare at the end of the year and see what we've seen. And then on the bottom left there, would be one unnamed member of the quantitative sciences group who was actually spotted in the last couple of years floating in a 12-foot inflatable unicorn. So with that, I'll launch into the stock assessment. Hopefully everybody's still on the line. You haven't hung up and discussed.
That was awesome. Thank you, Ian.
All right. So here we go.
Terrific. Very much appreciated.
All right. Well, we'll try to not get too stuck in the formal process and occasionally get you guys a little look at what it really looks like at the Halibut Commission. Okay, so what I'm going to cover in this presentation, and it is going to be fairly brief, I'm going to go through the SRB requests from SRB017 in June. I'm going to provide you with an update on new data sources for the 2020 stock assessment. I'll speak just very briefly to the bridging results and then to the remaining data for 2020. You'll note that everything that I've presented in this presentation, except that last slide, is contained in the document, so there's no new material. And if you want this presentation to follow along with, it is on the website. Those have been posted now. So there's a PDF of this presentation there as well. Okay, so with regard to SRB requests, there were 4 outstanding requests from the last meeting. The first was to explore the logistic normal for composition data, and I'll speak more to that. The second one was to update the data weighting after the final data were available for the 2020 stock assessment. At SRB016, we looked at how updating the data weighting would have performed over the last 3 or 4 years, and we concluded, I think, importantly, that this is a good thing to do, and so I'll be doing that after the last of the data are finalized. I don't have anything else to add on that topic at this point. I'll speak just briefly to the modeling framework considerations. We're using stock synthesis, and that comes with its pros and cons, as well as the data and final model updates expected for 2020. So now moving right into the SRB requests. The first request was to evaluate the logistic normal for composition data. We use currently in the stock assessment, we use a multinomial and we tune the sample sizes using the Francis method, which essentially compares the degree of fit to the input sample sizes associated with the composition data and makes sure that those two things are roughly commensurate. I think everybody knows the multinomial is not a great choice for stock assessment models. I spent a good chunk of last year evaluating the Dirichlet multinomial, which in some regards is a little bit better than the multinomial, but in many regards it's not very good and still not quite what we want. The SRB recommended at the last meeting, and I think it was an excellent recommendation, to investigate the logistic normal, which is one I had heard about, but really not spent much time looking at. So in the document, you'll find a little bit of a literature review on what I could dig up, at least in the last 10 or 15 years, on applications of the logistic normal. Some important aspects of the logistic normal that I find important, particularly for halibut. One, it's self-weighting, so we don't have to go through this iterative process of tuning the sample sizes. Two, based on the Francis 2014 paper, there's a pretty easy way to include the variability year to year in input sample sizes. And that's pretty important anytime you don't have constant sampling over time. And it's something that's often not included in when stock assessment data streams are built. They don't account for some years you might have 20 samples and other years you might have 200 or even 2,000. The logistic normal, importantly, allows for even potentially complex correlations among the bin structure of the composition data. And I think this is where it is a huge step forward from the multinomial and from the Dirichlet multinomial, neither of which allow for a complex correlation structure among bins. And I reference in the paper, Tim Miller and I think Chris Francis also looked at an empirical look at what correlations really look like in composition data due to bootstrapping. And they are, of course, much more complex than we are used to dealing with in the multinomial or even through the Dirichlet.
Excuse me, I'm sorry, Ian, this is Kim.
Yes.
What is a bin? A bin of what?
Sorry, yeah. So for compositional data in the halibut stock assessment, I'm just talking about age data. And so a bin would be the proportions of fish at a single age. And I call them bins rather than ages because generally we use a minus group at the lowest age that we want to deal with and a plus group at the largest age. And so everything in between is treated as individual ages.
Okay, thank you very much.
Yeah, thanks for that clarification. Sorry about that. One aspect of the logistic normal that is important is that it does not allow for zero proportions. And so I've worked on a number of species like rockfish where you might have 100 ages represented in the age composition data, and there dealing with especially internal zeros can be problematic. For Pacific halibut, this is really not going to be an issue because we already compress the distribution tails. I don't model fish for most data sets. I'm not modeling fish younger than either 2 or 4 years old, depending on the data source, and they're all compressed to either 20 or 25 years on the high side, depending on whether they come from a period when we had only surface aging, which becomes increasingly biased after age 20, or break and bake aging, which is good out at least to age 25. And beyond that, the proportions are so small, there's really little information. So those are important considerations for the logistic normal, but not going to be showstoppers for Pacific halibut. Internal binning would be an issue for some assessments, but a small constant and the fact that we basically don't have internal zeros to the age distribution data make this an easy choice for halibut. As I note in the document, Francis 2014 paper, I think it's called Moving Away from the Multinomial or something to that effect, is the primary discussion. And I actually hadn't reread that paper in a couple of years, and it is an excellent layout of all of these considerations. Essentially everything I've just told you, Chris Francis laid out in that paper 6 years ago. There were several other applications, published stock assessments and or methods papers that I was able to locate. John Schnoody's in there. Several other big names have used this likelihood, but they all had at least one shortcoming with regard to how we would like to apply this, this approach. I didn't find any applications that included more than an AR1 correlation structure among the bins. And while that might be okay if you just had unsexed information, I think it's going to be more complicated, and I'll speak to that a little bit more in a second. Most of the applications actually didn't include an accounting for interannual sample size variation, but Chris Francis laid out what I think is a pretty logical formula for doing that in the logistic normal. So the method is there for that. It doesn't require any development. Interestingly, none of the applications I could find actually fit to sex-specific data. They all had unsexed age compositions or perhaps size composition data. So the big extension, and this is identified again by Chris Francis, is moving from single-sex data, which is essentially a one-dimensional vector, to a sex-specific data, which is now 2 dimensions. And so I made a little cartoon just to help think about this a little bit. And the reason why we would expect this is that the proportions at age for males and females, we might expect some correlation structure, and it could be positive or negative depending on the data. We might expect some correlation structure among adjacent ages, but we would also expect some type of relationship between males and females of similar ages. And that's where I couldn't find anything in the literature that had gone down this avenue. I'm sure that there's an extensive amount of literature on 2-dimensional correlation structure. I mean, now we're basically talking about an analog to a spatial model, but none that's been actually adapted for use in the logistic normal that I could find. So I think that there are, with just a few considerations here, I think this could be a very promising avenue for the halibut assessment, given the data sets that we have, but it's going to require that we develop a new correlation structure to apply to that likelihood, so that we can maintain the sex-specific data that we use in the stock assessment. And so I'm suggesting for now, this essentially for this meeting, all I was able to do was a literature review and a summary of the topic, but I'm suggesting that for the spring, I'll provide another update. And what we're considering is that it actually could take a little bit of work to do this properly. We may need to either recruit a graduate student or perhaps a collaboration at least, because I think we're going to need to do some actual derivation or at least mapping of 2-dimensional correlation models into this likelihood function. And then I think before we just run away and use it in the assessment, we're going to want to simulation test it, at least under some reasonably easy conditions, make sure it works. Then we're going to have the step of actually programming it and implementing it in the stock assessment, whether we do that in a one-off version of stock synthesis or we work with the development team for stock synthesis to get that programmed in there. And then I think we're also going to ultimately want to test it for the halibut assessment before we move into necessarily just using it. But so that's the plan for this particular topic moving forward. And I can take questions as I go, or I can take them at the end. I'm happy either way. So please just speak up if there's a question as we go.
Sorry, Ian.
Yes, Sven.
Just very quickly, how does it work dealing with the fact when you have a changing stock, or does it not account for it, in the sense that your effective sample size, so the proportion of the stock you are sampling goes up when the stock is down and you take the same number of samples? Does it somehow take account of that? Or are you so far off the range that it probably doesn't matter?
I don't think, it's a good question. I don't think that any of the methods that are currently used for weighting are accounting for essentially changes in the quality of the sampling over time. I think the only way that you'd be able to accommodate that is through the input sample sizes. And there, I don't think anybody anymore advocates for nominal sample sizes. Generally, we're using the number of samples rather than the number of fish. But I think you're right. It's a fair point that the quality of a single sample could vary over time due to lots of things. But I'm not aware of any methods to deal with that. And I know that the iterative techniques that are being employed now are not really, you can't really apply those at the level of year-by-year observations. If you're iterating the scale of the input sample size, you're generally doing that for an entire data set rather than year to year. So that's an interesting question that I don't know anybody's made any progress on.
Thinking of the extreme scenario where you have very few fish, you're catching very few fish because there aren't many. And then it downweights that data and it takes, you end up with a biased estimate somehow. But I have to think about that a bit more. All right, thanks.
So I wanted to just ask a couple of questions here. So you have the original suggestion of the logistic normal was to address the self-weighting issue. So that's kind of the primary purpose. The secondary purpose is to account for potential correlation structure within the age, across ages. And then the third is to account for two-dimensional correlation in age and sex. So, I mean, I think maybe going for the full Monty there, it's almost, I think you're proposing to go for the full Monty and doing all the derivations to try to figure out the multidimensional correlation structure. I mean, we've used the logistic normal for sablefish since 2008, mainly for its self-weighting property. And recently we started using it for the correlation structure with Pacific herring, but they're not sexed. But even then, I mean, you can just assume the cross correlation across sex is not that, I don't want to say important, but you can ignore it for now, since it's probably going to be a tertiary effect at that point. Would that be fair?
Well, in some regards, yes, but the trouble we have is that the sex-specific information that we have in the age composition is critically important in the halibut assessment. And so to account for any correlation, we have to have a structure. The AR1 methods, the standard way to do this is to just take that cartoon on the bottom here and either put the males first or the females first and just treat it as one big vector. But if you do that, then any correlation structure is actually correlating, for example, the oldest males with the youngest females. Or you could reverse one and correlate the oldest males with the oldest females, but you'd still have some kind of an arbitrary correlation structure. So I guess I see, rather than sort of 3 steps, I see just 2 steps. One is we could do something like this and ignore the correlation structure and just use it for the properties of self-weighting, which would certainly be highly desirable and still accommodating the annual sample size stuff. But I don't see an intermediate in terms of using part of the correlation without getting it right, at least for halibut, because the male and female specific data is important enough, and the sex ratio is contained in these data. It's in that overall vector of proportions. So the way we have treated this is that the proportions sum to 1. I guess another alternative would be to fit these 2 separately and also provide the model with sex ratio proportions to fit to outside the composition data, but that would, in some ways, that would be double dipping on the data.
Well, I mean, I did that for Atlantic halibut, where it was length composition and then sex composition, and it actually seemed to work pretty well. I didn't dig into the details of why, but anyway.
I think that's a fair point. So there are potentially two intermediate applications. One would be ignoring the correlation and just using this as a self-weighting tool that would be convenient, which really actually wouldn't be much worse than using the multinomial, because it's not dealing with correlation structure either. And then the second would be a very simple correlation structure and or treating the sex ratio separately. I'm not sure how that would work though, because the real information from the sex ratio comes from the ratio at age. So that's where we learn the relative proportions of males and females at older ages tells us about the overall Z that's being exerted differently on the two sexes. Anyway, I'll move on. We can think about that and circle back to it as needed. So the second recommendation was just data weighting, and of course I'll be doing that after the stock assessment data are finalized. The data weighting will be the final step when I check for convergence and parameter estimates on bounds and all that sort of thing. So I've skipped over bullet 2 here with nothing to update. The third recommendation was to continue to evaluate the modeling framework. And as I mentioned, we are using stock synthesis as the software to conduct the assessment. It's convenient because I can fit four quite different stock assessment models in the same software and essentially get the same formatting in the output, which makes it very easy to do an ensemble assessment because everything comes out, no matter how I put it in, it all comes out in the same format and it's easy to integrate among the models. So I guess the developments this year were that we kind of have a standing relationship with the synthesis development team where we provide a prospectus on features and things that we would like to see in the future. Of course, we're in line with lots of other people, well behind the NOAA scientists who are closer to the product, but probably in league with the tuna commissions and other people that use this product in terms of where our requests fall. I'll note that as part of the 2019 assessment, we found that we didn't have access to a direct variance estimate on the unfished spawning biomass as a dynamic calculation, and we noted that, and in response to that, during 2020, that's now been added to the stock synthesis standard reporting. So we now have variance and covariance for that quantity. And I'll speak to that again in a couple of slides. So we've been able to improve our approximation there based on that improvement to the framework. So I think that's a good example of the pros and cons of using stock synthesis, is that sometimes we have to wait a bit to have a new feature put in, but we didn't actually have to put it in ourselves, and we didn't have to do a lot of the testing. So the quantitative team at the commission does have there is some benefit to not having to develop this stuff on our own. And I suspect we would, at least in the short term, go a similar route on new likelihoods as well. Although Alan and I have both used versions of stock synthesis that had custom modifications that we added. That is getting harder to do over time. The only other comment I wanted to make on this topic is just that and Alan's going to speak much more extensively to this, but the continued development of the MSC operating model, I think, is going to help us learn in the long run more about whether we are sort of stuck using synthesis and lacking features, or whether we can do a decent job approximating the things we need to. As the MSC process matures a little bit more and gets beyond just initial screening of management procedures and kind of getting off the ground, there are a variety of questions that can be asked there about model performance and identification of processes that may or may not be appropriate to include in the stock assessment, but we might want to at least evaluate those. And so I see moving forward, the decision of what modeling framework to use is going to be very tied to what we learn as we learn more about potentially about how the stock dynamics are operating, and or at least which of those dynamics are potentially most important to management procedures that the commission might be interested in. And so I think there'll be a two-way street there, feeding back and forth from what we learn in the MSE to what we are doing on the assessment side. And of course, and that's all assuming that we don't have, we don't move to some different type of management procedure, perhaps a survey-based management procedure, where if that were the case and we could extend out and have a 2 or 3 year assessment cycle, that would free us up to do a lot different kind of development on the stock assessment models. The fourth was just to provide, the fourth request from SRB017 was just to provide an update on both data and model considerations, realizing that this is our last check-in before the final 2020 stock assessment. And so essentially my goal every year is to make sure that we have made any structural change that we're going to make before this meeting, and to get as much of the new data into the model as I can, so that the potential for surprises after this review is as low as possible. And so this year, I've got several things. One, I've got some new data to put in. We have a software update, which I'll speak to. And then at the end, I'll just outline what data are still remaining for 2020. So the new data come from two sources. In June, I showed you the sex-specific age composition information from the recreational fishery in 3A. And so we've already talked about that briefly in June, but that remains a new source of information. We had previously unsexed age composition information from that data source. So this is a big improvement, although these data represent a much smaller component in the overall mortality. And so their feedback to the stock dynamics and the assessment results is much, much smaller than, for example, last year in the full assessment when we added sex-specific composition data for the directed commercial fishery, which comprises roughly 2/3 of the overall mortality. So the feedback there was much greater. Despite all the challenges we've had in 2020, Josep and his research team have managed to provide me with another year of sex-specific age composition information for the 2019 directed commercial fishery. You'll recall that we had 2017 and 2018 in time for last year's assessment, but we didn't yet have 2019. So this was great, and not only did they provide it, but they provided it early enough that I can even show it to you prior to the final stock assessment being put together. So the first piece that I mentioned is the recreational data. And again, we included this in June. It did show a slightly higher proportion female than we expected, but this had very little effect on the stock assessment for the reasons I mentioned. The new information, if I can get to the next slide, the new information here is another year of directed commercial fishery sex ratios. And so with just 2 years, we really had no idea or no ability to delineate between potential for trends versus just interannual variability. And honestly, with 3 years, we're not much farther ahead, although I think some interesting patterns have emerged here. So on the right-hand side of this figure, you see the sex ratio, the aggregate sex ratio in the fisheries by biological region, and for the 3 years, 17, 18, and 19. And my takeaway there is that the spatial patterns of a slightly higher proportion female in region 4, a little bit lower in 3, and much lower in 4B seem to be pretty comprehensive across the 3 years of data that we have now. So at first blush, it's nice to see some consistency in the data. The table here represents the proportions in the figures on the right, and it's also, I think, interesting that there does appear to be a trend over just these 3 years toward a slight decrease in the proportion female in the fisheries occurring in all of these biological regions. Noting that the one area where we see a pretty big difference from 2018 to 2019 in 4B, when I went back and looked, that's only based on sampling of between 10 and 17 trips per year for that entire region. That's the Western Aleutians. There's not a lot of biomass and not a lot of catch that comes from out there. So I'm not convinced that the drop from 65 to 51% is anything more than sampling variability, although with 3 data points, it's hard to delineate that. But I do think that there's some indication across all of these regions and at the coastwide level of a decrease in the sex ratio. And so when I dug a little bit deeper into this, go to my next slide, looking at the sex ratio at age to see whether some of this could be accounted for by a change in age structure. I think there's a little something else to be learned here. So the top panel is 2017, middle is 2018, bottom's 2019. It's age across the x-axis and the proportion female at that age by region. And again, you see some of the coherent pattern by region with the yellowish series being region 4, which consistently has the highest proportion female. And you see a lot of that's generated by fish that are, say, 13 years old and older, where the sex ratio remains highly skewed toward females, even out to older ages, although they're all getting back toward averaging around 0.5 by the time you get out to age 20. We think a lot of the difference at the younger ages is due to dimorphic growth and the fact that both due to the minimum size limit as well as just due to the use of relatively large hooks, young males tend to be much less available to the gear. And I think it's perfectly expected that, especially over the younger ages, say 8 to 10, we would see almost all females in the fishery landings, as these are the only fish that are both captured by the gear and large enough to be bigger than the minimum size limit. Now, thinking back to the patterns on the slide before, where we're seeing a decrease over the last 3 years, this is consistent with the interaction between these graphs and recruitment. So the last big year class we had was in 2005. And so that 2005 year class is moving its way essentially across the top of these figures. They would have been 14 years old in the 2019 data. And as you can see, on average, the proportion female from ages 12, 13, and 14 should be decreasing. And so I think that the patterns, to me, these patterns are fairly coherent, even without fitting any models to them, that this is consistent with the stock having a pretty big year class in 2005, which is moving forward. And we're seeing the sex ratio drift down toward a slightly higher percent males as that strong year class ages out. Now, of course, what we would really like, and this will come up under Joseph's topics later on, is to be able to go back and better understand on a decadal scale, as we have seen large swings in size at age, how these sex ratios could change. So I think we're just starting to understand a little bit of the dynamics of the interaction between the fishery and the sex ratios now with 3 years of data. Nonetheless, it's exciting to get these data in the model, and actually having 3 years, I'm starting to be sort of confident that what we're seeing is real, as opposed to just a year or two of sampling.
Ian, this is Kim.
Yes, Kim.
I don't know if it would be useful to talk about this in your presentation or associated with Joseph's data, but in the document 08, in the briefing materials and in some discussions that we had before the meeting, it appears that there may be a possibility of being able to extract DNA from historical preserve samples. And I guess from the stock assessment and MSE perspective, one of the questions that I have is that, given it's very time consuming to do this, both for the current year as well as going back to old samples, what years would be most important, or what intervals of sampling would be most important for the stock assessment and MSE? And the second question would be, how many samples would you need, given that you probably don't need the entire sample size for a single year to be able to get an accurate estimate by reporting region?
Yeah, thank you for the question, Kim. I think that's exactly where we're aiming our gaze from here on out. I actually just learned about the relative success that they had found in testing out this method of sampling some of the older otoliths. I just found out about that when I received the results that I'm showing you here for 2019. I'll recall, well, two things. One is, I think initially we would want to target a few periods corresponding to some of the biggest changes or biggest differences in the time series in size at age. So my first inclination would be to want to add some samples back in the late 1970s, where we think size at age was as large as it's been in the last 100 years. And then perhaps some samples from either side of that, so that we could better understand the interaction between size at age and sex ratio, because I think that is the primary driver of the sex ratios that we see, is this interaction between the size at age and the gear, and also the minimum size limit, which has been in place since the 1970s. Perhaps an analog for this question is that when I first arrived at the commission, we had some concerns about whether or not the whether or not the trends that we had estimated for size at age were real, or whether those trends could actually be due to a drift in our aging criteria over time. And the design that we took there in order to get at that question was we went back to each decade over the last 100 years now. We went all the way back into the 20s. And we selected a single year and 500 samples from each year, 1 year from each decade, all the way through the time series. And we re-aged those fish in order to be able to estimate a separate aging error matrix, essentially, for each of those time periods. So we could compare and see whether there'd been drift in the aging criteria. Now, there hadn't been in that case, but I think that would be sort of the next consideration after we had perhaps a sample at the peak and on either side of the peak of size at age. I would suggest some sort of systematic sampling back through the entire range of the time series would provide the most backbone for improving the estimates coming out of the stock assessment.
Good, thanks.
Ian?
Yes, Sven.
Sorry. Well, what about prioritizing some of the periods where there have been the largest fluctuations in fishing mortality? I mean, I know it changes relatively slowly, but there were periods where the SSB was very much higher, presumably through lower exploitation. I think that might give you an idea of whether there are changes that are associated with the selectivity issues. You know, you would expect if fishing mortality is low, you should see a different a different sex ratio at age progression, right?
Perhaps, yeah. And I think we could actually we would get some of that regardless if we sampled in the 70s at the peak of size at age, and then perhaps a decade or two after that on either side, we would get a pretty big range in exploitation rate as well, because we think that peak in size at age occurred in the late 1970s when the stock was about as small as we think it got. And so that would likely correspond with some relatively high exploitation rates, where a sample in, for example, in the early 1990s, and I think one consideration there would be the two short stock assessment models only extend back to 1992. So we would want to make sure that a sample in the 90s was late enough that we could use those data in all 4 stock assessment models. Once we get back past that time series, we're down to just the 2 long time series. So that would be another critical window, would be the early 1990s. Then that would correspond to a period of higher and increasing biomass, probably decreasing exploitation rates.
Thank you.
My guess is that this process would be slow enough that we could probably, essentially pick a year, do the work, and analyze it, and based on what we learn, refine what our suggestion would be for the next set of samples we'd like to do. But I'm just guessing. We haven't been through any kind of a planning process or cost analysis for those types of samples. So these data were included in a bridging analysis for the assessment. And I just want to make sure that I'm clear that I provided a short bridging analysis in June, where I showed you the sequential effects of the change in software, as well as adding the sex ratio data from the recreational fishery. But since there was an additional change in software since June, I basically went back and restarted so that anybody who's trying to understand this now can see the effect of the full software version change first, and then the incremental addition of each piece of data. So the bridging results in the document will not correspond exactly to what you saw in June. I've not even imported those into this presentation, because essentially there's nothing to see. the estimates of both spawning biomass and recruitment, and there are figures in the document for all of the models and all of the bridging, but there was very little change in any of them. The three steps, and I'll extend this out as I continue to add data this fall, were again, first to do the version update, then to add the recreational data, and then the commercial data. I do want to highlight one aspect of the synthesis version change, which I mentioned earlier with regard to development, which is that in 2019, we were approximating the variance of the unfished spawning biomass, and that's written up in the full stock assessment. We evaluated how to best approximate that variance and the covariance with spawning biomass so that we could get essentially a depletion or relative biomass level. Because this new feature was added, I made sure to get updated to the synthesis version that had the internal variance calculation. So now I have the variance as well as the covariance of this quantity with all other model quantities. And I redid the calculation, and I wanted to do this first so that we could see the difference in the reference point calculation. In this case, what I'm showing you is the relative spawning biomass projected for the beginning of 2021. So all the data is identical in both of these cases. And the only change is the upper row is using the approximation that we developed before we had access to the variance. And now the bottom row is the actual calculation using the Hessian and the asymptotic variance estimates. And I guess I'm kind of happy that we didn't do too bad. The relative spawning biomass changes a little, and it's moderately sensitive because we are close to 30%, which is where our current interim management procedure harvest control rule starts to reduce the target level of fishing intensity. But given an interval from roughly 20 to 46 or 47%, I think we did pretty well in terms of that approximation. And you can see the probability that the spawning biomass at the beginning of 2021 is below that level is unchanged, at least at the rounded percent level. And it's essentially unchanged for the probability of being below our 20% reference point as well. So we had a lot of transition in reference points last year, and I really struggled to make sure that people could isolate just the changes. So I wanted to really be clear this year and provide this table, and I'll carry this through various places so that people can see, okay, this is just purely a change in calculation. This has no data component to it, and it's an improvement. We now have a direct calculation as opposed to an approximation, and here's the effect on the relative spawning biomass. And I use 2021 because then we can extend this forward and actually see where we end up in exactly the same units when we have all the rest of the data included. So breathe a sigh of relief there. This was actually much closer than it could have been, given that we just did our best to come up with an approximation of that variance in the last full assessment. So as I mentioned, there are figures 2 through 5 in the document provide the bridging analysis for each of the stock assessment models, and they show each of these steps, but there really isn't, it's not worth going through those because there really was very little change. I will continue that bridging analysis through the remaining data sets and reweighting so that essentially, as I've tried to do for the last several years, somebody who's starting with last year's stock assessment can see the incremental change of each thing that happened over 2020 between the final assessment last year and the final assessment in 2020. And so all of the various steps will be included. Of course, the order in which you do them does matter, but I've tried to just keep them in a reasonably logical order. Software changes first, new data second, and then updates to existing data sources third, and then data for the current year at the end. Which brings us to data for the current year. So what's left? You've just heard from Ray that the 2020 fish results our boats are off the water. Ray's already got models done for the places where we had no new data and is working on models. As soon as we have the final QA/QC data, we'll have the trends and biological information from the FIS available for this survey. And again, from the assessment perspective, having a survey that covered approximately 70% of the stock this year and is going to produce a relatively tight CV leaves us in a very good situation for the assessment. I know many assessment authors are struggling with the lack of survey data and how to accommodate that additional uncertainty in their assessments, and that's certainly not a problem that we're going to have this year. Thankfully, we also had essentially business as usual sampling of the commercial fishery. So our port samplers, most of our port samplers actually live in the port in which they work, and the ones that didn't were able to get there and quarantine. And so we had both fishery logbook information and fishery biological sampling proceeded as normal this year. The fishery is still open, and in fact, it's been extended until the first week in December in Canada. It'll be ending on the 15th of November in the U.S. Or in Alaska. The fisheries are, I think, except the tribal fishery, are largely concluded down here in the lower 48. As we always do, we will have slightly incomplete data from the fishery at the time that I need to close the data sources. This generally has no effect on the age information. We have plenty of ages by the time the fishery closes to capture the annual mortality at age. And the logbooks, you may recall, do tend to have a slight bias at the end of the year. The missing logbooks that we get at the end of the year do tend to be slightly low, and the correction that we've come up with for that over the years, I believe it might even have been as long as 4 or 5 or even 6 years ago now, we developed this as part of the SRB process, is to inflate the variance on the logbook or the fishery CPUE information that I use in the stock assessment to account for the fact that it's more uncertain and potentially slightly biased in the terminal year. And when I present that information, I also present effectively a bias correction associated with the outstanding samples at the end of the year. And that ranges as a percent of the relative catch per unit effort. It ranges area by area. But that way, when people are interpreting, oh, it looks like this particular regulatory area went up or down, they can also have the context of how much that is likely to change when the rest of the fishery data come in for the terminal year. For the previous years, for example, for 2019, we will essentially have all the fishery logbooks now that we're going to get, with the odd exception, and those will all be included in this year's stock assessment. I'll also be waiting on biological information from other sources. These include both recreational and groundfish fisheries that are not targeting and can't retain halibut. So there's a fair bit of sampling that goes on there. Is used to inform the selectivity curves for those sources in the stock assessment model. And then the last source of new information will be the actual updated mortality estimates for 2020 for all of these sources, and any updates from what would have been preliminary values I used in last year's stock assessment for 2019. So we will update anything there that we have a better estimate for, and then we will add on the mortality estimates for 2020. And this really is the rest of the data that will go into the models. And so moving forward, before I go to the recommendations, once these data sets are in the model, the only thing left to do is to update the data weighting, check parameters and bounds and things, make sure nothing unexpected has happened, and then these models are done. So after this review in the fall, essentially there are no structural changes to the modeling. We can certainly field more of those for evaluation next June. But from here on out, I basically need to just finish up with data sources and turn the handle and see where we end up for 2020. So the recommendations for the SRB on this agenda item are to note this paper, providing you at least preliminary responses to the requests from SRB16, and an update on where we are, noting that from here on out, it's essentially just the outstanding data sources to go into the stock assessment model. If there are any recommendations you have for this year, it'd be great to have those sooner rather than later. I have approximately a month until I'll have the final data sets and be able to finalize the stock assessment. And then if there's anything else, and perhaps follow up on the logistic normal or any of these other topics, to provide those requests now. and I will be reporting back to you on those next June at SRB 18. So that's what I've got for you. Thanks.
Thanks, Ian. Just a quick follow-up on this last request. Do you use the synthesis executable, or do you have the ADMB version where you could actually try something, try coding a likelihood?
We have access to the underlying code, the TPL file, and I think both Alan and I have dabbled in modified code. I've done a few analyses where I've changed things. I did one where I added aging bias before that was available in synthesis, and looked at that effect. We generally use the stock executable just because I have seen some differences in performance among compilers and versions and things. So we try to make sure that we're using a version that's been tested by the development team for our primary stock assessment. But I think there's the potential that we can get in there and try a few things out before we ask for a full new feature or something.
Yeah, for research purposes, that probably would be fine. So I'm just wondering, how to scope any requests we might have on the logistic normal.
Yeah, I think that's something that we have a few options there. We can do some work outside of the model, just on looking at data and development from a statistical perspective. We can potentially put something in there and test it out. Perhaps one of these lower hanging fruit options that we discussed.
Mm-hmm.
And then, the full potential, I think, of the logistic normal is going to require a little bit more development.
Yeah.
But I appreciate your comment that we don't necessarily have to go all the way to perfect in our first try.
Okay. So if we have some other questions, Olaf?
Yeah, Ian, I just wanted to follow up on the logistic normal to make sure I understand the issue with not being able to look at correlation between males and females. Is that just a problem because it's suboptimal and that you don't get to use that borrowed information from the other sex, or is it a problem because it inflates the perceived sample size, degrees of freedom, because you're not taking that into account?
I'm going to go back to this cartoon here.
Yeah.
Here's the issue. So the sex-specific nature of the data, particularly the ratios at age, are critically important to the way we model selectivity by sex and natural mortality by sex in the assessment. We're essentially squeezing all the information out of the composition data that we can. The off-the-shelf, already figured out implementations of the logistic normal only include a single sex. And so they essentially, in this cartoon at the bottom here, they would just have one vector of ages.
Right.
And what that means is that all the correlation approaches that have been at least developed, to my understanding so far, the most common is an AR1 approach, which just uses the bin order as the basis for the correlation. And that just doesn't work for sex-specific data because you're modeling both vectors of bins at the same time. So essentially, Chris Francis notes this, that it's going to matter how you attach these two vectors together. If you put the females on one side or on the other side, it's going to change the apparent correlation structure. And he notes that as a problem, and disappointingly, being as smart as he is, he doesn't provide a nice solution. He just says this is kind of the outstanding problem with the logistic normal right now. And then he suggests that somebody should go away and figure out how to do this in 2 dimensions, and then it would be great. The problem for halibut is that we really do need the sex-specific information. I mean, a lot of assessments you can aggregate your composition data, and it's really not that big a deal. But for halibut, it really is a big deal. And so, as Sean and I were discussing, I think one approach would be to model the two vectors separately and then introduce sex ratio as another data source, but that loses the information at age. So
what about, Ian, what about modeling males like normal and then just doing a separate vector of the sex ratios. But I think that probably wouldn't be correlated and still gets you the same information.
Yeah, that would be one approach. I guess without thinking about it too much, my first concern would be how do you weight those two things? What would be the tuning metric? I don't want to trade one iterative tuning approach for another iterative tuning approach.
For sure.
And
Yeah.
ending up with now two data sets that I have to figure out the weighting for instead of just one.
Well, I mean, if I guess you could. This might be wrong, but assume that the weighting should be the same for the male and female vectors. And so instead of trying to figure out the weighting for the ratio, just treat the weighting the same for those two.
Yeah, that might be reasonable. I think the ratio at age would then have to have a likelihood specified for it as well.
Exactly. Yeah.
And I know in some cases that people do that in stock assessments. They'll use a sex ratio, an aggregate sex ratio over time, or I'm not sure I've actually seen a fitting to the sex ratio at age completely separately from age data. Mostly that's done when you have an aggregate sex ratio, so one observation per year, and then that's fit, as a proportion perhaps, or a variance inflated proportion of some sort.
Yeah, I don't fully understand the issue here, but I thought I'd throw that out there. It might not be feasible.
Yeah, I think this is a really interesting kind of frontier on stock assessment, and something that it's a hot topic. It's probably the main issue that came out of the data weighting CAPM workshop that occurred, I guess must have been 6 years ago now, that Chris originally presented this work in. But I was really hoping that I would find somebody had picked up on it and come up with a good solution to Chris's main problem. But apparently, at least to my knowledge, nobody's come up with that yet.
I think the ideal solution is to point out that this is a problem in some NOAA assessment somewhere so that they have to address it. The development team has to address it.
Well, they do respond pretty quickly usually when you offer to start programming it in yourself.
All
right.
That was a little shorter than planned, but that's what I had for you guys.
Short is always good. We're about a half an hour ahead of schedule. I got some information from our organizers that we don't have a draft or a template yet to work from for the report.
Sean, if I may, I'm going to send you by email the template that was used to create the SRB017 report. And maybe what I would suggest, if you would agree, is that you start using that template, which I started to change some of the dates around to populate the sections that you think are most appropriate.
Okay, great. That'd be great.
All right, I'll send that within the next few minutes.
Okay, thanks.
This is Ian. A question for you, Sean, and the rest of the SRB. We often populate that template with some placeholder bullets, just capturing some of the things that we've presented in the presentations. Right. Would you guys like us to send you a few boilerplate bullets that you can begin from, and then obviously modify as you see fit?
Yeah, I mean, that wouldn't hurt. I know others than me, especially. I mean, I appreciate how you guys conclude your talks with specific things you'd like us to comment on and things like that, just to make sure we don't miss things that you were hoping to get covered. So that would be great.
Okay, I think we can do that for today's presentations. If not this afternoon or this evening, at least by tomorrow, so that once you guys have some ideas about what things you want to comment on, you'll have a little bit of text from us to get started on the specific bullets.
Yeah, I know, following, these presentations, I don't see a big, long report coming out of this at this point. So I don't think we're going to have a big challenge drafting it. Okay, well, that takes us through the presentations, and our next agenda item is the drafting session, and maybe we can give Sven a break here and have a quick discussion amongst the SRB, have a brief drafting session just to get some ideas on the table, and then we'll, I guess, from that, we'll let Sven go to bed, and then we'll take a crack at the template and then send it out, and then we'll look at it again in the morning. We have Trevor coming at 10, so we'll have from an hour in the morning to have another look at the template. How does that sound? Any objections?
Sounds good.
And sounds good to me. I think last time we had some issues regarding letting people know that we're working on the report. But I think that's officially in the agenda this time, is it? The fact that it has to be a closed session tomorrow morning if we're working on the report, right?
Yeah, so we'll just make sure that it is a closed SRB session from 9 to 10 a.m.
You guys also be willing to just keep us informed by email where you are and let us know if we actually need to get back on at 10 or not?
Well, we will for sure tomorrow because Trevor is presenting at 10, so we'll be ready for sure at 10.
Right. Okay.
Yeah,
great.
Yeah. Okay, so for everyone except the SRB, we'll see you tomorrow morning at 10. And if we just have the SRB stick around now for however long we need to make a list of ideas.
Have a good night.
Thank you, everyone. See you tomorrow.
Bye. Talk to you tomorrow.
Sean, if I may, I just send out the email with the with an attachment with the template for the report. But please note that the text in there is coming from the SRB017 report.
It's just a question. So usually when the SRB is drafting a document, Sean or somebody has a computer with the screen there that we can all be looking at and editing. Is that possible here, or do we have to set that up tomorrow?
Is it possible?
No, I'm pretty sure I can share my screen.
Yeah.
I have the document here, so.
Yeah, you do? Okay, otherwise we could also do it from here. But if you prefer to do it on your computer, that's probably easier for you.
Yeah.
I think Sean is an organizer, so he should be able to do it. The rest of us can't. But at least this way we don't have the HDMI cable problems.
Okay.
Always a problem, that thing. I think we would have solved that by now. Okay.